I'll go ahead and get started. Good morning, everyone, and thank you for joining us for the Sarasota Bay Water Quality Restoration Workshop. My name is Darcy Young. I'm the Director of Planning and Communications for the Sarasota Bay Estuary Program. We're expecting about 260 people for the webinar today, which is a fantastic turnout. Before we get started, I have a few logistics to go over with you. First thing, please be aware that this webinar, including the chat, is being recorded, and the recordings will be posted on the Sarasota Bay Estuary Program website and YouTube channel. We're also planning to stream live to Facebook and YouTube. Secondly, we're looking forward to a great variety of speakers and topics today, and we expect a lot of great questions from the audience. Please enter your questions for speakers in the chat box. You'll see that there are two different options. There's the chat and the Q&A. We'll be primarily monitoring the chat box, so please enter your questions there. We have a tight agenda today, so we'll only address questions during the panel at the end of each session. So not every speaker will have a question and answer session after their talk. We'll be addressing questions during the panel at the end of each session. And we'll get to as many questions as we can. Third thing, if you have technical difficulties, please send a direct chat to me, Darcy Young, or to Christine Quigley. Or you can call our office at 941-955-8085, but it's going to be much more direct to just send us a chat message. And then finally, we have scheduled breaks at 10:50 a.m., noon, and 2:05. If a session ends early, the start times of those breaks might change, but the start time of each session will not. So we'll just try to stay on schedule that way. And we will put a countdown timer on screen for each of those breaks so you can check back to the screen and see when we'll be restarting. And now I will hand the mic over to our Executive Director, Dr. Dave Tomasco, to kick off the workshop.
Thanks a lot. So first off, I want to let everyone know we have 260 people. That's a lot of folks. Don't worry about logistics. If it takes you a little bit of time to get a presentation up, don't worry about it. You just saw I had a little bit of a technical glitch right there. So, you know, as we're moving forward in this COVID world with our workshops and all that, just breathe in, relax. If you're a presenter, it's all going to work out just fine. We wanted to start this workshop off with a welcome from U.S. Congressman Vern Buchanan. He represents most of our watershed. Congressman Buchanan couldn't be here in person today, so he took time out of his very busy schedule to shoot a video for us. The Congressman has actually got a really neat history that matches up really nicely with some of the things we want to do. He's, as you'll see, he grew up along some of the Great Lakes. He's originally from Michigan, went to college and graduate school up there, did a couple of years in the Air National Guard, came down to Florida, was a successful businessman, and he's a big supporter of environmental issues, lives on Longboat Key, so he lives within our watershed. Water quality means a lot to him, as it means a lot to his constituents. And the Lugar Center, named after former Senator Richard Lugar, termed him one of the most successful and one of the most bipartisan members of the U.S. Congress. And as a measure of that, he and Democrat Darren Soto from Central Florida recently initiated legislation to get manatees back onto the endangered species list. They were downgraded a few years ago. That was a mistake. And now the better protection that's being required for manatees, if it does happen at the federal level, it will be in large part due to Congressman Buchanan's action. So without further ado, let me turn it over to the video clip from our Congressman, and if you would be so kind, Darcy.
Sorry, folks, just one moment.
We're doing this as an exercise to make the rest of the speakers feel more confident.
Okay, Dave, actually, I might hand it to you to start your presentation, and then we can do the Congressman's video after you're done.
Okay, sounds good. All right, how's that working for you guys? All right, well, folks, I wanted to take time to thank everyone for carving out a big chunk of your day. This is not going to take the entire day, but it's going to take a lot of your day. And we thank you for that. But we also think that Sarasota Bay kind of deserves, a full day's attention from a lot of people. So with that, let's go through what we're going to talk about today. So our workshop is going to focus on some things that are going to be done really quickly. All right, why is water quality important? If we ask 10 people, we're going to get 10 different responses. And we want people to have whatever they view as their response, but we want to have a base of knowledge that people can build on when we talk about that. What is the current condition of the bay? You cannot manage Sarasota Bay or another system if you don't understand the current condition of that bay. So we're going to talk about that in a little bit of detail. What are the nutrient sources to the bay? A lot of what you're going to hear about this morning talks about nutrients, nutrient supply. It's not the only thing that we have to worry about in Sarasota Bay, but it's the most important thing for us to work on for managing Sarasota Bay. What has been done, what is being done to restore the bay's water quality. This is incredibly important, and we're going to spend most of the morning talking about activities to address stormwater and wastewater and what has been done and has it been important or not. Because one of the things we want to leave you with is we're actually farther down this pathway than a lot of people might think. And we're actually asking this question, which is, will the planned future efforts be sufficient for the re-restoration of Sarasota Bay? And that's important. We want to call it the re-restoration of Sarasota Bay because we've already done this once. We just have to do it again. And because we've done it once, we're more confident that we're going to be able to do it this second time. So why is water quality important? Again, ask a lot of people, you have a lot of different answers, but we want everyone to build off this one set of basic facts that we know. And one of them is a healthy bay is important to our quality of life. This is one of 28 NEPs across the country, and they all have a lot of things in common. Every estuary is going to be important for fish and crabs and shrimp. It's going to be important for resilience and shoreline stabilization, all these things. But if you're in Narragansett Bay or if you're in Puget Sound, you're not going to exactly have an awful lot of people doing what a lot of people in Sarasota Bay do, which is get out of the boat and hang around in waist deep water and just kind of enjoy the bay in this manner. And this is actually an important part of the quality of life. This is what a lot of people do. The picture on the right-hand side is Memorial Day weekend. It's not always like that, but a lot of our residents expect to be able to get out into Sarasota Bay, stand around in waist deep water, see their feet. They don't want to have macroalgae wrapping around their waist. They don't want to have smelly water and dead fish, that are affecting their weekends or their weekdays. And, in addition to the natural systems features, water clarity is a big part of what people expect to have from a healthy bay. It's also important to our economy. We have 20,000 jobs that are associated with bay-related activities, not the Gulf of Mexico, bay-related activities. We have the commercial fishing village of Cortez. We have recreational fishing guides. I have 2 of them who live on my street. We have the waiters and waitresses and bartenders and restaurant owners for bayfront properties. 20,000 jobs. We also have a property value uplift associated with proximity to the bay of about $3 billion. So people pay more dollar per square foot to live next to the bay than across the street. And they pay more across the street than a couple of blocks inland or a couple of miles inland. And the totality of that property value uplift is about $3 billion. Again, not to the Gulf of Mexico, to the bay. So it has a big impact on the ability of local governments to have enough taxes to pay for fire and police and schools and the National Estuary Program and all the people that are working on this system. And that's not a given. That actually works when proximity to the bay is an amenity, but that's not the way it was in Tampa Bay in the 1970s. And it really wasn't that way in Sarasota Bay back in 2018 when we had that wicked strong red tide. So proximity to the bay, the property value uplift, that's not a given. That is something that can go away if the bay's health starts to deteriorate. And other things are really important. Florida's saltwater wildlife heritage. In the first 6 months of this year, 2021, we lost more manatees than the worst year on record. The number of manatees that died in the state of Florida was more than 10% of the population last time we had a statewide population estimate. And the vast majority of the reasons why they died is starvation, the extra mortality. So what we have here, we're going to talk a lot about seagrasses and water clarity. And I now realize a lot of people might not know exactly what we mean. So seagrasses are not salt marsh grass. It's not stuff that grows in the intertidal zone that sticks up into the air. It's not the stuff that grows in dunes, sand dunes. It's plants that grow underwater at the bottom of Sarasota Bay. And anything that reduces water clarity, whether you make the water turbid, or whether you make it green, or whether you have a bunch of algae, is going to reduce the available light. And so things that affect water clarity or things that promote algal overgrowth are going to affect our ability to grow seagrass beds. So on the left-hand side, we got a picture of a manatee floating around with plenty of beautiful seagrass to eat. And manatees will eat about 100, 200 pounds a day. On the right-hand side is a photo from the east coast of Florida. And when I actually looked at it the first time, I didn't even know they were manatees. This is what manatees look like when they start to starve to death. And when they starve to death because they don't have enough food. This is what we don't want to have happen. This is from the Indian River Lagoon National Estuary Program's 2020 work plan. Picture on the left is from the Indian River Lagoon. The graphic on the right shows the trajectory of seagrasses over time. And what we see, those green bars, is a 60% decline in seagrass coverage over a decade. The remaining 40% is so sparse that the total biomass available food for manatees in Indian River Lagoon is down by about 90–95%. That's how you starve manatees, is by having the water quality problems we have. That is not what we want to have happen in Sarasota Bay. It wasn't expected in the Indian River Lagoon. It's not expected here, but it doesn't mean it couldn't happen if we're not careful about what we do moving forward. So what is the current condition of Sarasota Bay? We're going to talk a lot about nitrogen because the problems that we see on the last slide are due to an over-enrichment of that system with nutrients. What is Sarasota Bay like? Well, our nutrient of greatest concern is nitrogen. This graphic was produced, it's a variation of a graphic that was originally produced for Chesapeake Bay. It's from the University of Maryland, Bill Dennison's group. And it shows this overall pattern of moving from left to right of what happens to systems as you load them with nutrients. On the far left might be a place where, you might have very low levels of nutrients, something like, the Exuma Islands in the Bahamas, or maybe the dry Tortugas. That's not what Sarasota Bay ever was. That's not where we're going to get it to. That's not what we want. But we don't want it to be, the scenario farthest to the right, where nutrient loads have triggered a system where seagrasses and fisheries habitats of seagrass meadows and other parts of the bay don't exist because we've made the water too nutrient enriched. So what we're trying to do is we're trying to make Sarasota Bay look like the best version of what it can be. So we're trying to make it look like something right in the middle, optimal seagrass habitat, optimal fisheries habitat, not just for Sarasota Bay, but for each segment of Sarasota Bay, as you'll see moving forward. So we're going to talk about nutrient loads a lot. You're going to see a lot of presentations from our local governments about what they've done with stormwater, with wastewater, talking about nutrient loads. Why do we focus on nutrient loads? Well, first off, it's not a new approach. It's not a new approach here in Sarasota. It's not a new approach in Florida. It's not a new approach globally. nutrient management from the watershed has been worked on before in Tampa Bay and Sarasota Bay and the Chesapeake Bay and in Europe and in Australia. And the nice thing is that we can learn on what we've done already. Tampa Bay from the late 70s to the early 90s had almost a 60% nitrogen load reduction. That's just great news. That also took place about 30 years ago. We've been continuing to build upon that, but the big improvement took place a long time ago. Same thing in Sarasota Bay. We had about a 50% nutrient load reduction, but that took place about 30 years ago. And we need to basically make sure that we don't lose the benefits of what originally happened. But when those load reductions took place, we had system responses at an ecosystem level, not just a model, but actual collected data. So we know that water quality improved. We had improving trends in nitrogen, which fuels a lot of our algal growth, and reduced chlorophyll. Chlorophyll is an indicator of how much algae is in the water column. So both of those things have been reduced. We had improved water clarity. It's been documented over and over again for a couple of decades. And what happened when we reduced nutrient loads, when we improved water quality? We got one of our most important habitats back big time. This isn't just a Sarasota Bay scenario. The graphic on the right-hand side shows the seagrass recovery in 6 systems in West Central Florida: St. Joseph Sound, Clearwater Harbor, Tampa Bay, Sarasota Bay, Lemon Bay, and Charlotte Harbor. This data set ends in around 2016, and we have had some setbacks since then, but that doesn't reduce the importance of what you see in this graphic. So the value of 100 represents 100% of seagrass coverage as it existed in 1999. So let's just call it turn of the century. And so what you can see is every single one of those 6 systems by 2016 was higher than 100. Every single one of those systems had more seagrass in 2016 than they had turn of the century. Look at the gray line, that's Tampa Bay. That's a 70% increase in seagrass coverage over that time period. It's a remarkable recovery. It reflects 2 things. The load reductions, remember, about a 60% load reduction, about a 70% increase in seagrass. But also, it represents seagrass is growing back in areas where they've been lost. So it's also a measure of how much impact we've had. But look at the yellow line, that's Sarasota Bay, about a 50% increase in seagrass. We had a 50% load reduction, 50% increase in seagrass. So this is kind of an example of what we call the field of dreams approach. If you build it, they will come. If you get the water quality right, the habitat comes back. We didn't plant the seagrass increase. It came back by itself. And the totality across those 6 systems, 40 square miles. That's not 40 square miles of seagrass. That's 40 square miles of more seagrass associated with improved water quality, associated with these big load reductions. This is something that we want to build upon, but it's something we can learn from as what has already been implemented. So knowing this, what's the current condition of our bay? Well, we have a report card, whatever you want to call it, but we call it a report card, and it uses multiple metrics of the health of Sarasota Bay. And we're going to talk about this, but we also have a reference period that we use to report the report card. We don't know what Sarasota Bay was like 100 years ago. We don't know what it was like 50 years ago. The approach in Tampa Bay to figure out seagrass targets is based upon photography that can see the deep edge of seagrass meadows. We can't really see the deep edge of grass beds because they grow to like 10, 12 feet. We don't have photography in the 1940s that allows us to see the offshore edge of grass beds because it wasn't shot with the express purpose of mapping the habitats in Sarasota Bay. It was just like, there was a plane flying over, what does the photography look like? So, but we do know that not that long ago, about 10, 15 years ago, we had a healthier bay. Why do we know that? Bay-wide, we had a 28% increase in seagrass coverage. That doesn't happen if you have a system that's actually degrading. That only happens if you have a healthy system. We had lower levels of nitrogen in the bay. We'll show you that in just a few minutes. No bay segment was impaired for chlorophyll A. We have regulatory criteria about how much phytoplankton you can have in the water column, and none of our bay segments were impaired for chlorophyll back then. And we have macroalgae data. That's one of the last things for us to have data on is how much macroalgae do we have? And where we have the data, and it's most of the bay, we had lower levels of macroalgae. So we have multiple indicators of the health of the bay from a nutrient perspective that all indicate that we had a healthier system 2006 to 2012. We have real data on different parts of the bay on an annual basis. So that allows us to come up with a report card. So let's go through quickly how the report card was developed. Chlorophyll and total nitrogen are water chemistry measures. You dip a water bottle into the bay and you measure it. And for both of them, a big number is not where you want to be. So lots of nitrogen gives you lots of algae. So lots of chlorophyll means lots of algae is in there. So what we have is that reference period, 2006 to 2012, and we look at the average condition across each bay segment, segment by segment. We say this was a healthy bay back then. Here's our chlorophyll, here's our nitrogen. And then for every year, for every segment of our bay, we compare that year against that reference period. So if chlorophyll and nitrogen, a higher number is not where you want to be, then a value below the reference period mean or reference period average is a good thing. So we give it a score of 4. It's 1 to 4, that's all. 1 to 4, and a high score, it's like bowling. A high score is where you want to be. If you're higher than that reference period average, but you're within the standard deviation, we give you a 3, because it's maybe a little bit higher than average, but you're not that weird. If you're higher and you're outside of a standard deviation, then we give you a 2. So a standard deviation of normally distributed data should occur about once every 6 years. So if you're higher than that and you're outside of a standard deviation, we give you a 2. And if your value, so for example, if Little Sarasota Bay year 2018 has a chlorophyll value that's higher than the worst year in the reference period, we give you a 1, because that means you're worse than the worst portion of that reference period. Seagrass works the opposite. A big number is where you want to be. So if you're above the reference period mean, we give you a 4. If you're below it, but within a standard deviation, you get a 3. If you're below it and outside of a standard deviation, again, that should happen about once every 6 times, we give you a 2. And if your value is worse than the worst year, we'll give you a 1. For macroalgae, we use the same kind of scale that's done with Sarasota County for their NPDES permit, which is if you find a lot of macroalgae, that's not good, we'll give you a 1. If it's fairly uncommon, that is good, we'll give you a 4. So we have independent measurements of everything in here except the fish. So we have measures of water chemistry, nitrogen, chlorophyll, we have seagrass coverage, we have macroalgae, and this is our holistic indicator of how is the health of the bay. So the segments that we have, for those who are unfamiliar with Sarasota Bay, Palmasola Bay, the upper part of the bay, what some people call Big Bay, and then the lower part of the bay, we divide it into 3 segments: Rose Bay, Little Sarasota Bay, and Blackburn Bay. So we're going to show you the report card. And we color code it. Remember, it's just going on a scale of 1 to 4. And if you're in a certain higher category, you get blues and greens, because that kind of indicates that you're fairly similar to that reference period when we think the bay was healthier. If you have scores where the average is less than 1, is 1 or less, then we're going to give you a red. And so they're color coded. So the cooler colors represent better conditions. Yellow means kind of caution. Red means stop what you're doing, figure out what's going on. This is not a good place for you to be. So let's look at how it comes across. So this is our report card. First off, let's look at across the bay, 2006 to 2012, those first few years. Lots of red, lots of greens, lots of blues. That healthier bay was healthier across the bay. It's not like this was driven by one part of the bay being good and other parts being problematic. The bay was healthy across all of the bay. So lots of blues, lots of greens. This was a healthier bay back during that time period. If we look at Palmasola Bay, it stays blue. Palmasola Bay continues to be a healthy system. So regardless of the development around Palmasola Bay, regardless of some of the issues we have, it still appears to be a healthy bay. Doesn't mean it'll stay that way. It needs to be monitored. But right now, Palmasola Bay is an indication that we can actually manage our bay without it having declined over time. The upper part of the bay is a unique kind of story because blues and greens, but then it dips into the yellow, 2017 and 2018, then it bounces back into the green. And the reasons for that are different than the patterns that we see in the other parts of the bay. So the upper part of the bay was the epicenter of 2 strong red tides that we had, 2016 going into 2017 and 2018 going into 2019. And in between the 2, you had Hurricane Irma in 2017. So 2 red tides, 1 hurricane, you shifted to yellow. And what happens is we had reduced water clarity in upper Sarasota Bay to the extent where we lost about 2,000 acres of seagrass. It's a substantial loss of seagrass. But you'll note as well that it bounces back up into the green. And the reason why it bounces up into the green is because the water clarity has recovered. The water clarity up there right now is really good. You can see the bottom at 8 feet of water. That doesn't mean it's going to stay that way, but it does look like whatever was the problem that got us that seagrass loss has the potential to recover, because it has been, over time, has been one of the healthy parts of the bay. The phenomena in the lower part of the bay is very different. So what you see is Roberts Bay, Little Sarasota Bay, Blackburn Bay, they all shift into that yellow category back in 2013. You can't blame that on red tide. Red tide didn't happen back then. All three of them shift into the yellow. And we'll talk about the reasons for that in a little bit greater detail, particularly for Roberts Bay. But the neat thing about Roberts Bay is it shifts to yellow, then it bounces up to green. There is evidence of whatever was responsible for the declining water clarity and water quality in Roberts Bay. There's evidence of recent improvements. And we're not seeing quite the same evidence of improvement in Little Sarasota Bay and Blackburn Bay. So what we have here is not one way to manage the bay, not one way that's necessary. We see 4 different scenarios. Palmasola Bay was good, still looks good. Upper part of the bay looked pretty good, got hit with a red tide, looks like it's got its water quality back. And then the lower part of the bay, where we had a setback in around 2013, and then some evidence of improvement in Roberts Bay, but things we still need to act upon in Little Sarasota Bay and Blackbird Bay. So our bay-wide indicator of ecosystem health, seagrass. Remember what we showed you from Indian River Lagoon, 60% acreage decline. We're not there, but we're a third of the way there. 22% decline since 2016. That's not good. We don't want to follow that same trajectory of losing more and more seagrass. We want this and turn around, but it's not going to happen with just goodwill. All right, it's going to take action for us to do this. But we are not in a good place right now for our seagrass coverage. We want to halt that decline. We want to turn it around. And if we do that, I think good things will happen. And I think, as you'll see for the rest of the day, there are a lot of people committed to making sure that we do the things that are necessary to get our seagrass back. So part of that is nutrient sources. What are the nutrient sources to the bay? A lot of places, what you'll do, you jump right into a pollutant loading model. And we have one. We have a really good pollutant loading model. But our approach here is a little bit different. We're going to do 2 things. We're going to use our pollutant loading model, but we're also going to use water quality to verify or to highlight some of the things that the loading model might be telling us, or maybe some of the things that a nutrient loading model might have missed. So we have a very good loading model. There's been a number of loading models done for Sarasota Bay. The one we have now is, I think, the best one that has been done for this system, but it's not perfect. But we can't wait for perfect knowledge. If we wait for perfect knowledge, we're going to spend 10 years studying the bay, and that's not what people expect us to do. So let's talk about the water quality data and the pollutant loading model, how we can merge them together to come up with what kind of things should we pay attention to. This is a lot of water quality data. This is Roberts Bay. Roberts Bay is the drainage, receives drainage from Philippi Creek, which is fully 1/3 of our watershed. The data on the left-hand side is the raw data. If we just run stats on it, we would find a trend of increasing nitrogen. You could have like a graphic with an arrow that points up. And that would be true. There's nothing wrong with that, but it's not as illustrative as you can get when you look at the data in different ways. So on the right-hand side, what we've done is we've taken all that raw data, we've turned it into annual geometric means. That's what AGM stands for. It's kind of like an arithmetic average. And the green box represents those years 2013 onwards. So remember, we shifted into the yellow in that time period. And we'll talk about what might have happened in that time period. But the green box represents 7 years, 2013 onwards. That red horizontal line represents the highest annual average nitrogen of the preceding 15 years. And what you can see is in that green box, 5 of those 7 years have nitrogen concentrations not higher than average, higher than the worst year of the prior 15. And of those red stars represent years where we exceeded our chlorophyll criteria. So we're impaired for too much algae in the water column. And 5 of those 7 years, we have nitrogen higher than the highest in the last 7. So those 5 years would be getting a score of 1. They're outside of the highest value recorded. So this is what we've got in Roberts Bay. We've got more nitrogen, we've got more phytoplankton, we're not showing it here, more macroalgae, and we've lost seagrass in that system. But one of the neat things is, look at the last couple of years here. The last couple of years don't show a continued increase in nitrogen. It doesn't show the nitrogen continuing to go up. It actually looks like a trend of it going down. So maybe this is just, something strange that happened and it's going to reverse itself. Or maybe it represents something real that we need to pay a little bit more attention to. So now we're going to work from the bay up into the watershed. That's what this graphic is. This graphic represents nitrogen concentrations in Philippi Creek at US 41, the farthest downstream site that we have. The individual dots are individual monthly measurements of nitrogen concentrations. I want to give a big shout out to folks from Manatee County and Sarasota County, Moat Marine Lab, who have been collecting or analyzing this data for decades. This is how you manage a bay with good data sets, and we have good data sets. So if you look at the cloud of data there, again, if you just ran a statistical test, you would find an overall increase. You could put a graphic with an arrow pointing upwards, but it's really more complex than that. The red line represents the mathematical equation that best explains the variability in this data set. It's a polynomial equation. And if you watch the red line, it goes up and it goes down. And that's really what your eye sees. So let your eye kind of tell you what's going on. It's not just a pattern of it going up, it's going up and going down. So what in the world could have happened at this site to allow for nitrogen to go up and go down? Is it urbanization? If so, what do we do? Take people out of the watershed? No. That's where the yellow box comes into play. And the yellow box helps us understand the things that we might need to do to manage Sarasota Bay. That yellow box represents multiple years during which we had overflows from a storage pond from a wastewater treatment plant that was not at AWT levels. Now, AWT, you're going to hear a lot about that today. AWT in our region means nutrient removal technology, a Barden-Foe process, link nitrification, denitrification. The end result is a nitrogen concentration that by law would have to be less than 3 milligrams per liter. This particular plant was not an AWT plant. And during those years, they had overflows from a storage pond of in excess of 700 million gallons. The right-hand side of that yellow box represents the end of those discharges. So what we kind of see is the time period during which we had overflows seems to match up with both the increase and, when the overflows ended, the decrease in nitrogen. That allows us to understand what we might want to act upon. These overflows occurred miles away from the bay, but it looks like they explain some of the nitrogen increase in the creek and the nitrogen increase in the bay and the algal increase and the seagrass loss. And what that suggests to us is that our pollutant loading model should incorporate things like overflows, what we might want to call spills. And it might want to be a benefit to have that plant upgrade to AWT. And as you'll see later this morning, that's exactly what's going to happen. That plant is going to upgrade AWT so that if we did have a future spill in that system, it wouldn't come out at like 18 milligrams per liter. It might come out at 1.8 milligrams per liter. So let's talk about the loading model. We're getting close to the end, folks. We have a nutrient loading model done by Tony Janicki and his folks. I want to give a shout out to Tony and also to John Perry and to Mike Wessel. This is a very good model. It's not perfect, but no model is perfect. It builds upon the earlier efforts with Jones Edmonds of the simple model. But what it does is it has neighborhood level estimates of reclaimed water use and runoff and septic tanks and just a really great level of spatial detail. And it has the ability to be updated if we find new information. So if we look at that reference period, we look at the last couple of years, we see that when we compare the two, the nutrient loads have gone up about 20%, total nitrogen loads. So this is actually kind of an indication that maybe one of the reasons why we transitioned to a less healthy system is because our nutrient loads went up. But one of the best things about this nutrient loading model is it goes beyond total nitrogen and it does dissolve inorganic nitrogen. So not all nutrient loads are equally problematic in terms of creating algal blooms. If you load nitrogen, and I'm exaggerating a little bit here, but if you load nitrogen in the forms of sticks and leaves and insect wings, that nitrogen is not going to be 100% available for algal growth. Depends upon the residence time of the water it's loaded into. If it comes in as dissolved inorganic nitrogen, it's going to be immediately available for algal growth. So our DIN loading model suggests that our dissolved inorganic nitrogen, mostly nitrate, has increased by about 12 tons between the time period when we were a healthier bay and the time period where we've actually had not as healthy a system. So you can see where we're going to go here, hopefully. So really the question is, could we reduce inorganic nitrogen loads by 12 tons? Is it possible, or is that just a pipe dream? The loading model suggests it should be possible. The totality of reclaimed water. Now, we want to be careful. When we talk about reclaimed water, not all reclaimed water is the same, but reclaimed water with a relatively low nutrient concentration is not going to be much of a problem. But as you'll see from Abby's talk later on, reclaimed water with a lot of nitrogen can be a problem, particularly if you fertilize on top of it. And so reclaimed water is not just one thing. Our models have to be sophisticated enough to pick up the variety of nutrient loading possibilities. But reclaimed water, spills, septic tanks, when you combine all three of those are controllable. Those are actual nutrient loads, and they're far in excess of the DIN increase that we've seen from that reference period the last couple of years. So we have enough that we could act upon to get us back to the nutrient loads that we want to do. And one of the neat things about this workshop is we're going to see from the totality of the projects that are already on track to happen, whether or not we have enough to get us back on track. So almost done. Is it realistic to be optimistic with everything that we need to do? And so if we look at the graphic right here, it shows the blue, this is nitrogen concentrations, annual averages from the open waters of Sarasota Bay. The blue is that reference period, and the red is the more recent years. And so what we're really talking about is, can we shift the valleys in red back to the valleys in blue? And it seems like a really tough thing to expect that we could be able to do that. But if you look at the totality of the data set, look what we've already done. Remember, we had a 50% load reduction in this bay, roughly, and it occurred right around the late 80s, early 90s. Look what we've already done to improve Sarasota Bay. So yeah, we have a challenge moving forward, but we've already done more than what we're potentially going to be required to do moving forward. So with that, the rest of this workshop, what we're going to talk about is what's already been done, what we're planning on doing to address water quality issues in the bay. We're going to talk about wastewater and stormwater. We're going to talk about traditional types of infrastructure by local governments. Why? Because it's worked, because we've seen the benefits that are happening again. But we're also going to talk about non-traditional efforts. We're going to talk about things like stream restoration and how that might fit in there. We're going to talk about nitrate reduction via some really sophisticated techniques Steve Swa is going to talk about. We're going to talk about public education. Abby's talk is going to talk about how we can better educate the public to not abuse the resource of reclaimed water. And then we're going to talk about various in-water efforts, because you can't fix Sarasota Bay by putting more filter feeders out and planting seagrass because you want it to grow. But that doesn't mean you shouldn't do those sort of things. It just means put it into perspective. We're not suggesting that we can fix the bay by putting clams and oysters and putting seagrass out there because we want them to be there, but they have a role to play. We don't just focus on the watershed, we focus on in the water as well. And then moving forward, as we tie it back in the afternoon, we want to get to these questions. What will be the cumulative impact of these future projects? We have a lot that's, actually planned. And will it be enough to get where we want to be? And with that, I think I'm done here.
All right. Thanks very much, Dave, for the great introduction. I've got my ducks in a row now, so I'm going to play our welcome video from Representative Buchanan.
Thanks, Dave, for the introduction and putting together today's workshop to identify strategies to restore water quality in Sarasota Bay. In this region, we rely on clean water and white sandy beaches for our economy and our quality of life. Our bay and our beaches are why many tourists visit here, and it's why many visitors move here. Our fish and wildlife also rely on good water quality. As a kid growing up near Lake Erie, I can tell you, if you caught a fish or if you're swimming, but if you caught a fish, you couldn't eat it. And I want to make sure that doesn't happen in our region here locally. In recent years, we've been plagued by red tide. This harmful algae bloom has had a very damaging impact on water quality, marine life, and the economy. I helped secure millions of dollars in federal funding for red tide research. Scientists agree that humans don't create red tide, but we can make it worse. We need to protect our shores and our bays. 25 years of this partnership help improve water quality in the bay, but we have recently seen a decline. We need to reduce pollution going into the bay. I applaud all of you for coming together today to set goals and develop strategies that make sense going forward. I look forward to working with you to protect these vital natural resources for our economy today and into the future. Thanks, and have a great meeting.
Okay, and thank you very much to the Congressman for providing us with that video introduction. And now I am going to welcome our panelists for session one, which is local government actions to reduce nutrient loads to Sarasota Bay. Our moderator for the morning session is John Thaxton. John is the Senior Vice President for Community Investment at the Gulf Coast Community Foundation. Among many other things, John is a former Sarasota County Commissioner and one-time member of the Sarasota Bay Estuary Program Policy Board. Thank you, John, for taking the helm of our morning session. Each local government has been invited to present for 20 minutes. There will be a 20-minute panel discussion and Q&A session following the presentations. And please just remember to put your questions into the chat box. We can also address any questions that you had about Dave's morning presentation during that Q&A session. With no further ado, here is John.
Thank you, Darcy. Darcy, if you could please confirm that you can hear me fine. And
yes, I can.
Okay. All right, thank you. I first want to apologize for any background noise that you might hear. My wife and I are on vacation, and I am moderating this panel from San Antonio, Texas. And where I'm sitting right now is just a short distance from a train track. So if you hear the rumblings of a train, it's not an earthquake. And if you hear the horns of the train, you'll know why. I too want to thank my fellow moderators, the panelists, the Congressman, and the participants for joining us this morning. I'd like to kind of just reframe what we've just heard briefly from Dr. Tomaska. And I think we can take a lesson from corporate America here. The Sarasota Bay, including its nearshore Gulf of Mexico and the bays, bayous, and stream, are the brand for our community. And if you would like evidence of this, I would challenge you to go to virtually any website that promotes and sells Sarasota County, such as our Chamber of Commerce, our Economic Development Corporations, our realtors, et cetera, et cetera, et cetera. And it's hard to find one of those sites without the opening image being a beautiful shot of our aqua-colored bay and Gulf of Mexico. So I don't think it's possible to overstate the significance of this bay system to our economy, our ecology, and our social network. And as anyone in that manages brand will tell you, brands are difficult to maintain, and once you lose them, they're almost impossible to get back. So I would suggest that we do not want to become a community that is known for harmful algal blooms and dying ecosystems, but one that, as the Congressman said, where you can go swimming and eat the fish from the water. I also appreciate the recent focus on nutrients. I'll revert to a more informal Dave, as opposed to Dr. Tomasko referenced. I can remember 15, 20 years ago working on the CCMP with the Sarasota Bay program, and the scientists and everyone knew the relevance of nutrients, but the general public did not. The general public, if you were to approach them about nutrients, they would just simply suggest that the more nutrients, the better, because things grew faster, things grew better. So I appreciate the focus on the anthropogenic nutrients that we now recognize are causing a lot of our water quality degradation in Sarasota Bay. I'd also call your attention to the format of the agenda, because I think that it speaks to the need of a public-private collaboration as a solution, probably the only solution to persistent public policy issues such as water quality. As Darcy said, our speakers this morning will be the government speakers. They will be referencing both the retrospective and a prospective approach to water quality and what they have done and what their role is in implementing the CCMP, which is, of course, the Comprehensive Conservation Management Plan. We will have the questions at the end, but please put them in the chat. I am not going to go into lengthy bios. If you would like to know the educational background, what football team these individuals like to follow, or what ice cream flavors are their favorites, I would instruct you to just go to a search engine and look them up earlier. And also a note to our speakers, a good example of how to reference one of the technical things is when Dave talked about the DIN, and he explained it in a bad way is when he talked about the NPDS, the National Pollution Discharge Elimination System. He did not, so it would be helpful to all if we use some of these technical terms that we gave a brief explanation of them. And with no further ado, I want to get right into our first speakers. We're going to begin with Manatee County government. And we have at least two representatives from Manatee County. The first is Jeff Goodwin. He is the Deputy Director of Manatee County Utilities. Welcome and thank you, Jeff. And secondly, we have Greg Blanchard, the Environmental Program Manager for Air and Watershed Management for Manatee County Parks and Natural Resource Departments. So Jeff and Greg, I will turn it over to you.
Thank you, John. Just confirming that I can be heard. Jeff Goodwin here. As mentioned, I'm the Deputy Director of Utilities for Manatee County. I'm going to make an attempt to now share my screen. And confirming that could be seen as well.
We don't see it, Jeff. I do have
Appreciate
your presentation here. So if you need me to share it, just let me know.
Did I hear that you cannot see my screen at the moment?
Correct. We cannot see it.
Yeah, if any technical help would be appreciated.
Sure. I'll just share the presentation for you and you just let me know when you want me to advance.
Thank
Give me
you.
one moment.
I did.
For those who are wondering, we have the ability to do this for every presentation. We can give it ourselves if there's an issue.
Thank you, Darcy. I appreciate it. Again, thanks for allowing Manatee County to share some of their efforts, at least from a utilities perspective, on helping to improve water quality in our area. If you can advance to the first slide, please. Just a quick overview of our wastewater program. We serve nearly 300,000 residents and wholesale customers. This includes all three island communities, and Longboat Key is a wholesale customer to the county. We have 3 water reclamation facilities, total permitted capacity of 33.5 million gallons a day. We are currently treating about 25 million gallons per day. We have a fairly extensive reclaim distribution and delivery system. As you can see, we're distributing and delivering close to 80% of what we treat for irrigation purposes to residential, agricultural, golf courses, ball fields, etc. This system is interconnected between the 3 water reclamation facilities, so we can move we can move the reclaimed water in any direction that we need to, depending on demands. We're nearly at 1,800 miles of sewer pipe at the moment. That continues to grow as most of you know, the growth in our area is taking off again. We're up to around 710 lift stations to help pump the sewage to the treatment plants. Currently, we have 181 positions within the wastewater program, and as you'll see later in the presentation, we're getting ready to add to that number. Operation budgets for the next 2 fiscal years, nearly in. This is significant increase over the last several years as our operations have continued to grow, our additional infrastructure added to the system, and some of the regulatory requirements becoming such that we have to have more folks to help manage that. You can move forward to the next one, Darcy, please. So some of our past projects and initiatives, two of our 3 water reclamation facilities were treating to an advanced secondary treatment level that included the modified Luxic-Ettinger treatment process, which allowed us to treat more nitrogen levels in our wastewater. Our oldest and largest facility, our Southwest facility, was conventional secondary treatment, and the nitrogen levels were much higher coming out of that plant. We implemented a project, as you can see, to the tune of about 21 million, and in 2017, that came online, and we were able to reduce our nitrogen levels from that plant to about 40%. Our goal was to get it under 10 milligrams per liter of nitrogen going out into our reclaim system. And we have since optimized that since that's been online. And we're actually able to produce a water quality of less than 7.5 milligrams per liter of nitrogen. Additionally, we've optimized some of our treatment at our Southeast plant most recently, and those numbers actually have dropped below 6 milligrams per liter. Our North plant historically has been our best performing plant in regards to nutrient removal. Unfortunately, we've had some operational issues, but once those are resolved, those numbers will be similar to the other 2 as far as water quality. Next bullet point, please. So simultaneously with our water quality, our efforts to improve water quality in our system, we had some storage and disposal capacity issues. And so the county was challenged with managing the storage of their reclaimed water during the wet weather season. And we did have a number of unauthorized discharges from our storage facilities. So even though we had 1.2 billion gallons of storage capacity, wet weather in Florida, as the utility folks know, is a challenge for us. And so in order to resolve that, we added to our deep injection well system a second well. It's a class 5 recharge well at our Southwest plant. It gave us an additional 15 million gallons of disposal capacity, along with our Cortez Road class 1 deep injection well. That gives us nearly 30 million gallons of disposal capacity per day. So we've pretty much resolved our unauthorized discharge issues. We have not had a discharge from any of our storage facilities in over 8 years now. Next bullet point, please. Along with the class 5 recharge well, we put in a system at our North plant to ensure that we had proper disposal capacity. That class 1 well came online last year, and the class 5 well, we're currently working with the department on our operational permit. That'll give us an additional 6 million gallons a day of disposal capacity. So again, the county's issues with treated effluent, reclaimed water, escaping from storage facilities have been resolved. Next bullet point, please. Once we address water quality within our system and disposal capacity issues within our system, we turned our attention to our collection system, and we wanted to focus on sanitary sewer overflows, and knowing that those have big impacts on water quality. And I should mention the obvious, a lot of our infrastructure is in close proximity to several sensitive surface bodies, including Sarasota Bay, Terracea, Manatee River, Tampa Bay, Braden River. So we're very, very sensitive to managing and operating our system such that we don't impact those surface bodies or have minimal impact as we can. So in the last 5 years, we've invested, or reinvested, I should say, in our collection system about $60 million. We spent a little above $60 million to replace and repair some of our aging infrastructure. We do a thorough evaluation of the need in the system with help from our engineer of record, and we prioritize based on age of the infrastructure, construction materials, and proximity or the potential for impacts to surface bodies. So $60 million in the past 5 years, reinvestment into aging infrastructure, and we've seen a nice decrease in these breaks in the system that allow the sewage to escape and get into the environment. Next bullet point, please. We also implemented a computerized maintenance management system throughout our wastewater department to about $3 million. This allows our folks to stay ahead of their preventive maintenance program and keep an eye on aging assets so we get those replaced before they fail and cause issues within the system. And we were proactive in implementing a capacity management operations maintenance program, which the department was very pleased with, although it comes with additional expense to the utilities. It's well worth the effort. Next slide, please. Some of our ongoing and future projects and initiatives we do routinely from our operating budgets. We spend about $900,000 a year to do lining within our sewer system, both our laterals and main lining. Next bullet point. About $100K to do smoke testing to identify where we might have leaks in the system, where inflow infiltration can cause overflows and therefore, again, negative impacts to the environment. Next bullet point, please. We're looking at our manholes, inspections, repair, and we've started a program for insert installations, all about at a cost of about $835,000 a year. Inserts in the manholes prevent the stormwater, or at least minimize the amount of stormwater that enter the system, overwhelm your pump stations and avoid those sanitary sewer overflows. Next bullet point. So for our next 5 years, 22 through 27, we've actually allocated $140 million to continue our reinvestment in our collection system. Again, the goal is to reduce and minimize the potential for sanitary sewer overflows. The increase in cost is associated with the fact that we've evaluated our gravity sewer system, and the utility folks on the call know that that's the more expensive part of your system, your collection system. So we've committed to another $140 million, $200 million over, that would add up to $200 million over the previous 5 and the next 5. To again prevent or minimize at least the potentials for those overflows. Next bullet point, please. We are adding 7 positions within the next 2 fiscal years at a cost of about $434,000 per year. Again, so that we can maintain the systems properly, avoid failures in the system, so that we can avoid the negative impacts to the environment. And I'm trying to stay on task here, so I'd be happy to answer questions when it comes time for the Q&A session.
Thank you very much, Jeff.
Thanks, Jeff. So Jeff, we also had listed here, Greg Blanchard. Is Greg with us, and will he be able to?
Yes, I am. Can you hear me?
I can hear you, Greg. You're on, my good man.
Darcy, can you do the same thing for me that you did with Jeff? I'm getting some internet connection stability warnings here. All right, thank you. For those of you who don't know me, I'm with the Parks and Natural Resources Department, and one of my charges is to help protect the water quality of Sarasota Bay. If you will advance to the next slide, Darcy. My remarks today reflect the part of a countywide stormwater nutrient reduction program that I operate that basically is direct runoff to Sarasota Bay watershed. This is sort of limit the scope of my presentation. The orange area in the chart shown is the approximate extent of the watershed that has direct runoff to Sarasota Bay. It's about 34 square miles in area. Within this, there's a section where the City of Bradenton manages stormwater, and that is in the black hatching. And I also remind everybody that stormwater from major FDOT facilities passes through this area to Sarasota Bay. FDOT is a co-permittee in Manatee County's municipal stormwater permit and benefits from its compliance activities. If you'll advance to the next slide, Darcy. So I'll introduce our Coastal Watershed Program. Manatee County's Coastal Watershed Program is a roughly 15-year effort to reduce nutrient loads from stormwater runoff originating in the old coastal urban watersheds of Manatee County. And as I mentioned, it is countywide. The Coastal Watershed Program leverages watershed and stormwater system engineering studies by the Manatee County Public Works Department and adds water quality assessment studies and evaluations to these efforts. The water quality studies are scoped to identify cost-efficient watershed scale stormwater nutrient reduction opportunities. Individually, I'll refer to these as water quality improvements for the rest of the talk. Water quality improvements that come out of these efforts may be structural or non-structural, gray or green infrastructure, or other innovative solutions. And because we're the Parks Department, conceptual designs may include valuable or attractive community amenities in older neighborhoods that may not have any. The Coastal Watershed Program remains on schedule. It's just about 2 years from launch and is meeting current performance metrics. We've started the 3rd water quality study started under the aegis of the Coastal Watershed Program this fiscal year in the Pierce Drain Gap Creek watershed. And we advance the slide, Darcy. This slide summarizes our current efforts. Current Coastal Watershed Program water quality studies follow the structural and flood protection priorities of the Public Works Department. The reason is it's simply much more cost efficient to coordinate efforts this way. Both studies draw on the same data, and it's very useful that this data be current at the time that the work is done. 2 watershed water quality studies are currently underway in Southwest District, Sarasota Bay contributing watershed, Police Creek and Pierce Drain Gap Creek. Additional work in both watersheds are planned and will follow. Manatee County provides stream gauge and water quality data required for both the engineering and water quality studies. This has required the expansion of both of these data collection programs to meet current needs. And finally, the Coastal Watershed Program goals are also advanced by our municipal stormwater permit compliance activities, which are summarized and reported annually. Next slide, please. Our future efforts will include an engineering and water quality study that has already been proposed to funding agencies for the Cedar Hammock Palmasola Bay watershed. A project supported by the Sarasota Bay Estuary Program has completed a conceptual design for a green infrastructure demonstration project at GT Bray Park that, when built, will help us promote similar improvements elsewhere. We seek funding to build water quality improvements identified by the Coastal Watershed Program separately outside the normal Coastal Watershed Program project calendar. Funds appear to be available to start 3 smaller projects this fiscal year, and we will be pursuing these. But the process for the larger proposals is complex and lengthy. The Parks and Natural Resources Department is working with our Public Works Department on a process to add significant water quality improvements to separate flood protection and maintenance projects that they may arrange. Parks and Natural Resources Department will also create a process to add significant water quality improvements to separate resiliency projects. However, these are funded and managed. And final slide. Unfortunately, due to the age of our program, I don't have a grand tabulation of how much we spent so far, but we're very serious about our investments in Sarasota Bay water quality. Public Works engineering studies cost about $46,500 per square mile. And remember, I said the total watershed is 34 square miles. Water quality studies about $3,000 to $11,000 per square mile, depending upon complexity. Water quality improvements proposed by these water quality studies are between $50,000 to $2 million apiece. The stream gauge and water quality monitoring data system that we need is also a real cost. However, there are multiple uses for this data, so we don't really charge it to this account. The entire project receives technical support as benefit from a $600,000 per 5-year performance period Restore direct component grant. So if you're wondering how we use our Restore direct component money, this is a major consumer, a major user of that source of funding. That is all I have to say at the moment. I'll be happy to answer questions when we have a break. It looks like I am pretty close to on time. Thank you all.
Greg, I would say that you are precisely on time. So thank you and Jeff for following all the rules. I think the trend is emerging here that while this is a shared responsibility between both the government and the private sector, it's pretty obvious that the government sector is going to be responsible for a larger share of the burden of water quality probably than the private sector. Again, a reminder to put your questions in the chat. I have 1 or 2 already. I will be monitoring those as best that I can. Encourage you to be civil, but also encourage you to not hold back on the punches. If you have a poignant question to ask, please feel free to get it in there. And so now we are going to move to Sarasota County, and we have joining us this morning Amanda Boone, who is the Senior Manager for Stormwater for Sarasota County Public Works, and Mike Milet, who is the Director of Sarasota County Public Utilities. So Amanda and Mike, I will turn it over to you, and whichever one of you wants to go first, I'll leave that up to y'all. Thank you very much for joining us.
Good morning. Can everyone see my screen and hear me just fine? Fantastic. So again, Amanda Boone with Sarasota County Stormwater Environmental Utility. And as we go through our slides today, I first want to point out that, in the past, the primary focus of our projects has been flood control. That's not to say that they haven't had water quality benefits, but to be fair, we've had a lot of flooding issues that needed to be resolved, and we've done a great job at that. But in the future, our focus is really going to shift towards the water quality and making improvements there. Now, the utility does have a variety of responsibilities. This includes an interlocal agreement with the City of Sarasota, maintenance and planning across the county, capital improvement projects, our development standards enforcement, NPDES compliance, and our TMDL management. Now, our list of past projects, you'll recognize a number of these are Celery Fields and Donna Bay, Catfish Creek, Sediment Traps, Hudson Bayou, and the 10th Street Baffle Box. Now, the primary benefits from these projects have included flooding reduction, the creation, restoration, or enhancement of wetlands, hydrologic restoration, nitrogen and phosphorus removal, sediment capture, and trash capture. Now, the secondary benefits from these projects have included increased home values, increased tourism, and increased recreational amenities. We have several ongoing projects that make a difference to our bays. The first of this is our aquatic weed harvesting program. Now, aquatic weeds in our areas can damage stormwater structures, block drainage, and pollute our waters with nutrients when they die and decay. So the county is actually evaluating an expanded effort to remove aquatic weeds from our county stormwater facilities, including those like Donna Bay, as it may provide a very attractive cost to benefit ratio in terms of nutrient removal. Now, our water goats help to prevent floating debris or trash from flowing downstream to our bays. And lastly, our NEST program seeks to educate the public and guide them towards best management practices to improve water quality. Now, as I move forward and start talking about some of our future projects, the NEST program and their involvement has become very important and will be very obvious. But first, the challenges as we move forward. On the map shown, beige is residential, gray is commercial, transportation, or industrial. Green is recreational, ag, or open space. And bright green is golf courses. So you can see the landscape outside our preserved areas is mostly developed. And the coast was developed before stormwater treatment was required. That's why you'll see that the ponds are mostly to the east and south and demonstrate the stormwater treated areas. So the two major challenges when it comes to future projects are very limited land area is available. And because of this limited area, the areas we have to work have constraints that escalate the cost. So not much publicly owned property, but we do own the drainage system, including about 280 ponds. So our future projects, I am really excited about. They are going to be new for Sarasota County. They're going to be new for the area, but they're not new to the country as a whole. Stream restoration has been going on in other areas of the country for quite some time, but they're expensive projects. Again, they're being done in areas that are very constrained. They have utility conflicts. They have ownership conflicts, but we need to realize the full benefit of these projects. Now, the Alligator Creek Stream Restoration Project is moving forward currently. It is outside the Sarasota Bay Estuary Program boundary, but I wanted to include it to give some perspective on the cost you're seeing here. So Alligator Creek is about 0.75 miles of headwater restoration, about 0.75 miles of mid-order. Whereas Philippi Central provides 2.95 of headwater and 1.61 of mid-order. And Philippi Creek Northwest is nearly 20 miles of headwater restoration and 4.24 miles of mid-order restoration. So it gives you some idea of why you're seeing such a stark difference in the cost. Now, restoring Philippi Creek could have a very significant influence on the Sarasota Bay Estuary Program area, as it is the largest watershed within the boundaries at about 36,417 acres, or 38% of the watershed. So here we can start to see that those primary benefits are expanding and having a greater impact. So again, we have the creation and restoration or enhancement of wetlands, but now also our streams. We still have hydrologic restoration, but now we're including floodplain restoration. We have our nitrogen and phosphorus removal, but we're moving towards bank stabilization instead of sediment capture. Now, the secondary benefits from these projects, again, they include the increased home values, increased tourism, and increased recreational amenities. But now we're going to start to add an enhanced aquatic habitat, especially for fisheries. Now, next, our pond management and retrofit. Now, within the Sarasota Bay Estuary Program area of Sarasota County, there are 2,315 ponds. That is a lot of ponds. Of these, though, only about 176 or 13% are county owned. So again, that coordination with our private owners of ponds is going to become very important. What we have reason to believe is that our ponds have been in service for so long that they may actually be evolving into a pollution source with the eroding banks, the excess sediment, and decaying vegetation. So what we're looking to do as far as pond management and retrofit is to provide a no-mow perimeter area, native vegetation, and increased maintenance, including sediment removal. Again, we look to include our private ponds in this or work with them as partners using some of our collaborators like the Estuary Program or the START program. Pardon me. And lastly, we are looking at the feasibility of incentivizing the urban retrofits, or LID, to provide water quality improvement in our urbanized areas. So with that, I will turn it over to Mike Milet with Utilities.
Good morning. From a utility perspective, a lot of people assume the Philippi Creek Septic System Replacement Program was pretty much the county's first initiative into the water quality, water improvement segment, but it really wasn't. You need to step back a little bit and look back in the 1980s and 90s when Sarasota County started to implement the franchise consolidation plan. In the mid to late 90s, there were over 110 package plants in Sarasota County. Today, there are 21. So that removing all those individual point sources and putting them into regional facilities has been a huge improvement in our water quality moving forward. The Septic System Replacement Program for Philippi Creek alone brought almost 10,000 customers off of septic systems and into a regional treatment facility. You know, that project by itself costs in the neighborhood of $115 million. Next. As we move forward, or as we continue to look back, actually, the county many years ago created a lift station rehab program to address some of the ongoing maintenance issues at the lift stations. As was pointed out previously, municipalities and counties have to invest a lot of money into their collection system in order to prevent those SSOs. And over the years, we've created a rehab program specifically aimed at our lift stations, where we target about 40 lift stations a year for rehab work. Now that puts us on a 20-year cycle in order to get through all of our 735 lift stations in the county. Over the last 5 years, we've put over $10 million into that program alone. Next. Hand in hand with the lift station rehab program is what we label as our I&I, our inflow and infiltration reduction program. And this portion is aimed at our manholes and sanitary sewer lining projects. Over the last 5 years, we've been able to line over 70 miles of sanitary sewer that's clay in our system, which was a big source of inflow and infiltration, adding to the volume of water necessary to be treated in our collection system and treatment system. Next. A lot of these projects on the screen here, I'll talk about individually as we move forward. Go ahead. Many of you are aware that Sarasota County has taken the initiative to upgrade all of their regional wastewater treatment facilities to advanced wastewater treatment. That means that we'll be able to reduce the nitrogen in our treated effluent to below 3 milligrams per liter. That's the ultimate goal for all of our facilities. Our first facility that we're working on is our Bee Ridge facility out at the end of Bee Ridge Road. That's our largest facility. We're also expanding the capacity of that facility by 50%. That'll be an 18 million gallon a day facility when it's done in 2025. The Board of County Commissioners just recently approved a week or two ago the start of our Venice Gardens project. Our Venice Gardens AWT expansion and conversion project will expand the capacity of that facility by probably 100% when it's done. So that project's looking at about a $90 million, and we're bringing that in probably in finished 2026. And then that'll leave us just our Central County facility, which will probably kick off in 24, 25 as we wrap up our Bee Ridge facility. Go ahead. These are the specifics of some of the projects we listed on the other slide, but we have an ASR, an aquifer storage and recovery well at our Central County facility that helps with, as was mentioned before, effluent and storage capabilities. People know that during the summer, when it's raining, we have a lot of reclaimed water and no one wants it because it's raining. But during the winter, we have a challenge of keeping up with the demand for reclaimed water. So aquifer storage and recovery systems help meet that demand. In addition, we also have a deep injection well system at our Central County facility that we can use to get rid of the excess reclaimed water when we don't have storage available for it. Next. Our Siesta Key Master Pump Station Force Main project removed a treatment facility from a vulnerable barrier island location and installed over 7 miles of large diameter force main to get that flow to a mainland treatment facility, basically our Central County facility at this point. That was a huge vulnerability to have that treatment facility out on the island. Storms were a challenge during maintaining operations at that facility. Next. As the county moves forward into looking at future septic system programs, we're currently studying the availability of the location of all of our existing systems in our service area and throughout the county. We have approximately 50,000 septic systems remaining in Sarasota County. Of that, about 24,000 of those are in the Sarasota County service area. When we look at what it's going to take to connect those septic systems into a central regional facility, it's somewhere in the neighborhood of $500 million to $1 billion that we're looking at. So just between the treatment plant upgrades and the septic system program, we're looking at close to $1.5 billion worth of improvements necessary moving forward in our system. Next slide. As was mentioned by Manatee County, Sarasota is working on implementation of a CMOM program. The CMOM program is the best practices for operating your collection system, your wastewater collection system, to help reduce the SSOs. Sarasota County is currently in year 3 of a 5-year implementation plan. We've completed one of our studies on our north collection system and are currently studying our central and south collection system to identify all the improvements necessary. So all those numbers, those billions of dollars that I've talked about, will continue to grow as we identify additional improvements necessary in the system. In addition, as Manatee County pointed out, just operating wise, it takes more effort, more people, more equipment to efficiently operate a system to maintain reliability and compliance. And with that, I'll be happy to answer any questions.
Thank you, Mike. Let's hold the questions until we finish with the 2 municipalities that we have queued up to speak. And I have received numerous questions now in the chat. I have them all recorded, so we will get to as many of them as we possibly can. But just one shameless plug here. I did not ask Dave for permission to do this, but I'm going to do it anyways, Dave. And that is a plug for the Gulf Coast Community Foundation's Water Quality Playbook. It is available online, and many of the questions that I see here and a lot of the information that you hear from our speakers are included in the playbook in a very digestible form that explains a lot of the nomenclature that people are having difficulties to understand, as well as a very simplified opportunity cost analysis or ROI review that gives some guidance on which of these water quality improvements make the most sense in terms of economic return. So again, Darcy, if maybe you can put that link up there, that would be very helpful. It is a kind playbook. It is all science-based, and it is designed in a way that other communities can replicate it. And I'm very proud to be a part of that effort with the Science Foundation here. I'm sorry, I got the name wrong, Dave and Jennifer. Okay, so we move on now to the City of Bradenton. Due to some health reasons, the representative from the city was not able to join us. And so Dr. Dave Tomasco is going to assume that role. And Dave, it's all yours.
Thanks, John. So I want to make very clear, the presentation was created by the City of Bradenton, but I'm not going to answer questions about it, but I'm going to describe what's on the slides. And I want to thank Jim McClellan for putting this together. He, above and beyond, for helping us out here. We asked him for an email to put stuff together. He put a whole presentation together. So we're really happy about that. So next slide, please, Darcy. So a couple of things about the City of Bradenton. Bradenton has, like all our municipalities, they have responsibility for stormwater, for wastewater, all the other things that local government has to take care of, schools and police and all these other things. But we're going to focus on their wastewater and stormwater infrastructure. 200 miles of gravity sewer, over 4,000 manholes, 60 sewer lift stations, 37 miles of pressure sewer. So a pressure sewer would be where a lift station moves sewage to the next lift station. You'll see this from Longboat Key in the city of Sarasota as well. 151 miles of storm sewers, over 6,000 manholes and catch basins associated with their storm sewer, and 9 million gallon per day wastewater treatment plant. And one of the neat things about the City of Bradenton is they were in this early, like 30-year ago, adopter of AWT. So as Mike Milet talked about earlier, AWT in our neck of the woods stands for nutrient removal technology to get nitrogen down to about 3 milligrams per liter. And so they've had an AWT plant for about 30 years, I believe. Next one, please. So you've heard an awful lot about the efforts that have been put in place for maintaining the wastewater infrastructure. And this is incredibly important because leaks from an aging infrastructure, and a lot of our infrastructure is 50, 60 or more years old, can be not only a problem for wastewater backing up into people's houses. That certainly is the priority issue, but also that is a source of bacteria and nutrients that can come into creeks, ditches, and get into our bay. And so if you can see the amount of effort that they put into their maintaining their wastewater infrastructure, it can vary from a couple of 100 feet a year to a couple of miles per year. And so Jim broke it down in terms of how many miles, how many feet, and the totality over this time period from the last 7 years, 2014 to 2021, is 5 miles of wastewater pipes that have been lined or replaced because of cracking, because of infiltration with roots. That's about 10% of the total amount that they have, but it's the 10% priority. And that's about $3 million. Next one, please. The storm sewer improvements include an awful lot. And one of the things about the City of Bradenton is there's parts of the City of Bradenton that drain right into Sarasota Bay. There's parts of the City of Bradenton that drain into the Manatee River. And the Manatee River is not actually in our watershed the way it's defined, but we don't care, because the reality is, particularly in an incoming tide, Manatee River discharges come around the corner, move to the south, and come into Sarasota Bay. So we help promote activities in that part of Bradenton that are directly coming into our bay and those that go into Manatee River, because a healthy Manatee River is going to make for a healthier Sarasota Bay. So we have listing a whole bunch of that same 7-year time period, all these projects that are meant to improve stormwater. And the way stormwater is improved now is not the way it used to be. In the past, stormwater improvement simply meant putting it into pipe and discharging as quickly as you can, because the only thing that was considered, frankly, was flood control. And that's not the way anymore. But these total capital improvement projects get to about a little bit more than $5 million. Now, one of the neat things is, if this picture, when you first look at it, it may not mean much to you, but look at that median strip. That median strip has these little sort of like cuts that come into the side, and the median strip is depressed below the elevation of the roads. A typical median strip in a typical highway built not just in Florida, but all around the country, would be a raised median strip with a curb that goes along it, and there's no way for the water to go anywhere but to the side. And when it goes to the side, in older parts of our watershed, it typically goes to a curb, to a gutter, to an inlet that goes to a pipe that shoots it straight out to the bay. But what we have right here is a depressed median strip that actually functions like a sort of a dry retention system, an infiltration basin. We have soils in Florida that have a good combination of air temperature in the soils and organic content below the surface that can do a really good job of treating some of the things that come off of our roadways, pet waste, grass clippings, that sort of stuff. So getting as many opportunities as possible to get stormwater to infiltrate into the aquifer is a much better approach to dealing with stormwater than simply putting it into a pipe and shunting it straight out to the bay. So this is just an example of what can be done to actually help reduce flooding in a way that's environmentally beneficial. Next slide, please. The wastewater treatment plant, as we said, is several decades old, and it doesn't continue to work the way we want it to work unless you put a lot of money into it on a regular basis. So again, during this 7-year period here, you can't just build a wastewater treatment plant and walk away. You have to build it and you have to maintain it, and you have to improve it as things break down, as new approaches make a lot of sense. So one of the things that we see is about $11 million that has been spent for maintaining this wastewater treatment plant. And so $11 million helps to basically make the effluent that it produces as good of a quality as you might hope to get from a structure that was built many decades ago. But it is an AWT plant. When it has discharges, for the most part, those nutrient concentrations are going to be lower than a non-AWT plant. Next slide, please. Force main improvements. So part of dealing with wastewater is dealing not only with the gravity lines, but also with the force mains. So the force mains, and this is a really neat picture because it kind of shows just how close some of these sewer lines are to the waters that we're trying to protect. So the capital improvements for maintaining the force mains in this area is about $2 million. So $2 million spent to maintain the force main in this particular area for this wastewater plant. Next one, please. So this is really kind of neat. So the City of Bradenton, like all wastewater treatment plants, is going to have, glitches that happen. It's going to have issues that pop up every once in a while. Aging infrastructure, it's true. But it's an AWT plant. Under Grizzle Fig, it's allowed to have a surface discharge. Doesn't mean this individual permit allows it to be 100%. But the City of Tampa, for example, 100% discharge basically of effluent because it meets these Grizzle Fig criteria of nutrient removal technology. So does the City of Bradenton. But City of Bradenton has actually entered into partnership with BRU. BRU stands for the Braden River Utilities and Lakewood Ranch. If you're familiar with this area, you know where Lakewood Ranch is. If you're not, it's a new development that's centered around Manatee and Sarasota County. It's actually not new anymore, but it's a large number of houses, thousands of houses. And when you build thousands of houses, you have parks, you have soccer fields and baseball fields, and you have yards. And irrigation is something that happens in Florida. Irrigation demand is typically met in lots of places by basically taking drinking water and spreading it across grass. And what we're doing in this part of Florida is we maximize the reclaimed water use. And that does a couple of things. It reduces the demand for drinking water as a source of water supply for irrigation. And it also reduces the likelihood of having nutrient loads go into the bay by using them for growing grass. And you can overwhelm it, it's true. But what we have right here is an AWT plant that actually is taking about 6 million gallons a day. Remember, it's a 9 million gallon a day facility, and shipping it 10 miles to the east to go to Lakewood Ranch to serve as a water supply. As you'll see later from Abby's presentation, the majority of the water that's delivered for reclaimed water goes to public areas, so ballparks and soccer fields and things like that. And it was paid for by the Water Management District and Braden River Utilities. Didn't cost the city anything, didn't cost me anything because they didn't have to do this. They entered into this relationship to reduce it. Even though they got an AWT plant, although they do have discharges, this reduces by about 2/3 the nutrient loads that would normally go out to the Manatee River now go towards application for reclaimed water farther to the east. Next one, please. So future sewer improvements are expected. A lot of this is just capital improvement. So as you know, aging wastewater is not anything that anyone likes to have, but it's a reality of what we have in Florida. So Annually, they spend about $1 million a year. So the next 5 years, can spend about $5 million. Next one, please. I believe the next one might be the last one. Future stormwater system improvements. They're looking to spend actually a little bit more money on stormwater improvements moving forward. Village of the Arts needs improvements. It basically does have flooding problems when it rains pretty heavily in that area. It's just south of downtown Bradenton. So they're actually looking to spend more money on storm sewer improvements over the next couple of years than they have over the last couple of years. And I believe that's it. Maybe there's one more. Of course, there is one more. I forgot about the big one. So the 5-year plan for the wastewater treatment plant. So the wastewater treatment plant has a couple of needs that are necessary, and that is to increase the amount of storage capacity. As Mike Milet talked about earlier, in the dry season, everyone wants reclaimed water. In the wet season, no one wants reclaimed water. So what do? You have to have a storage capacity for it. Part of that is with the first bullet line there, and then part of it also is reclaimed water injection well. So in other words, the injection well is not of raw sewage, it's not of partially treated sewage, it's basically of effluent that right now gets discharged into Tampa Bay, for example, from the city of Tampa. This would be at that level of treatment, but going into a deep well injection so that there's no surface discharge. And that is it. If you have questions, please contact Jim McClellan. It is not appropriate for me to answer any questions you might have about this. Thank you.
Thank you, Dave. If I didn't know better, I would say you were interviewing for a position at the City of Bradenton. They should maybe think about it if not. So on our agenda now, first off, let me give an apology to the Science and Environmental Council of Southwest Florida, specifically to Doctors Jennifer and Dave Schaefer for their involvement in the water quality playbook. I misspoke earlier. And also a shout out to Steve Squall, who you're going to hear from later in the day. The three of them are the principal authors for the playbook. And as mentioned in the chat, all of the valuable information that we're getting here today will be incorporated into the playbook so that it will be relevant and current for all of the users. So we are on time. We have scheduled between 10:50 and 11 o'clock bio break. If you would, we will return promptly at 11. And Darcy, is there anything else that you would like to add before we sign off, or Dave? We do have a couple minutes of freeboard here.
No, I'd just like to thank you and the speakers who have already gone and encourage everyone to stick around for the panel and Q&A session that we will have after our speakers from City of Bradenton and Town of Longboat Key. So I'm going to pop up a slide here that shows how much time we have. Sorry.
Darcy? Yeah, it's the City of Sarasota and Longboat Key.
I'm sorry, City of Sarasota.
That's okay. Sorry.
Thank you. So I will pop up a slide here with a countdown timer, and we will see everybody back at 11 o'clock.
Darcy, are we back?
We are back. Yes.
All right. Any welcome back comments, or would you like for me to just progress with the agenda?
We can progress with the agenda. We're ready to go.
Yeah, that sounds good for me. And so welcome back, everyone. Again, my name is John Paxton. I'm the Senior Vice President for the Gulf Coast Community Foundation. And this, we will proceed with our agenda. And the next two speakers are from two municipalities in both the County of Sarasota and the County of Manatee. Longboat Key, of course, sharing boundaries with both. We'll begin with Bill Reeby. He is the director of the City of Sarasota County Utilities. And again, we have invited our government officials to share with us both a retrospective and a prospective look at how their work is advancing the goals of the Comprehensive Conservation Management Plan, the CCMP. And again, I will ask the speakers to, if they use any sort of acronyms, to please explain them as best that we can. We've had several comments in the chat box where people are frustrated not being able to follow because of the text that we use. And we do want to make this as user-friendly as possible. And of course, it being recorded, other folks that are not joining us today will also need to have access to the information, and they will not have the advantage of asking questions of our speakers. It's also been noted that all of the slide presentations and the agenda will be made available to anyone and everyone that would like them in the public domain, if you would. And so, Mr. Reeby, if you are ready, sir, I will pass the floor on to you.
Give me 1 second here.
Take your time, sir.
Having some technical issues.
Bill, if you have continued issues and you want to, we can display it for you and just tell us.
Yeah, let's do that. That'd be easier. That's fine. That's fine.
And thank you, Darcy, for having this alternative presentation mode in place. Well done.
All right. Again, my name is Bill Reeby. I'm the Utilities Director with the City of Sarasota. Next slide, please. So the City of Sarasota, we have multiple departments within the city that share the responsibility for water quality, with responsibilities ranging from regulation and development and enforcement to public outreach and education to administration of the city's MS4 program. That's in conjunction with Sarasota County. And finally, to the delivery of capital projects. Next slide, please. The focus of the city's water quality program is real simple: reduce nutrient and pollutant loads and promote a sustainable and healthy ecosystem. As you know, the city of Sarasota is located on Sarasota Bay. We understand the importance of the bay and water quality and what it means to the residents who live here, businesses, and all the visitors that are attracted to the city. Next slide, please. To promote these goals, the city has recently completed several projects at a total cost of approximately $101 million, with $1.5 million dedicated to stormwater and about $100 million dedicated to wastewater projects. Next slide, please. Stormwater capital projects include a living shoreline, a living seawall, bioswales. This is one example of a bioswale that the city's installed, and a baffle box in conjunction with Sarasota County. All of these projects are geared to reduce nutrient loads, promote healthy ecosystems, and also remove nutrients. Next slide, please. Along with a lot of these capital projects, the city also implemented several non-capital initiatives, including water goats, which are used to remove trash from streams and creeks, ditches, public outreach and volunteer cleanup events. These are really, really important. It engages the public, helps in, portray or convey the importance of environmental, the environment and the importance of the bay. We've also installed these little simple boxes for toy storage at Lido Beach. This is, kids bring toys to the beach, and oftentimes they're left on the beach. They end up out in the Gulf and places where we don't want them to be. So that's kind of a simple thing, but important. We also have the city's MS4 program. You see a copy of this, a picture of the street sweeper there. The city's, sweeps it, cleans its streets daily, removing all kinds of pollutants from the roadways. so they don't get into storm drains and ultimately into the bay. Next slide, please. On the wastewater side, the city has completed multiple capital projects. Probably the biggest one, which occurred decades ago, is the city converted its wastewater treatment plant to advanced treatment. This plant has a capacity of 10.2 million gallons per day and produces high-level disinfected reclaimed water with extremely low nutrient levels sufficient for safe disposal to surface water. As you can see on the slide, the nutrient levels are extremely low. In addition to that, more recently, the city also constructed a deep injection well to provide for wet weather disposal of treated high-level disinfected water or reclaimed water. As you know, or many of you know, or some don't, all of our reclaimed water, we use about 80% to 90% of our reclaimed water is used for beneficial use. It's used for irrigation, makeup water for HVAC, cooling towers, those kinds of things. So next slide, please. The city also has completed several wastewater projects totaling $57.5 million. These projects are geared to reduce sanitary sewer overflows and, of course, the associated nutrient loads of raw wastewater, including the replacement of force main piping, lift stations, and gravity sewer. On the slide, you can see there we just completed about a 6,000, 7,000 foot run of 24-inch force main right through the middle of town. We use directional drilling there to reduce the disruption to our residents. In the middle is a photograph of our new lift station 87. It's a beautiful building, a beautiful facility. It pumps wastewater to our wastewater plant. And then the last slide is deep sewer that was installed as part of that lift station 87 project. Next slide, please. Along with these projects, in addition to the replacement of the wastewater facilities, the city also has invested $35 million to rehabilitate existing facilities, including the lining of sewer mains and laterals and manholes, restoration of lift stations, smaller lift stations. We've outfitted with generators to make them more resilient. And also we installed a new reclaimed water filter at our advanced wastewater treatment plant to ensure that we continue to produce water with low in nutrients and high level, and disinfected. Next slide, please. Looking forward, the city plans to invest approximately $193 million in future water quality projects, with $27.5 million specific to stormwater and $165 million specific to wastewater. Next slide, please. A key stormwater project designed to improve water quality in the Philippi Creek watershed is the construction of a creative wetland at the city's Bobby Jones Golf Course. When complete, significant reductions in total nitrogen, total phosphorus, and suspended solids will occur. The estimated cost of this project is about $7.5 million. Next slide, please. Another key stormwater project is part of the Bay Park program located around the Van Wezel Performing Arts Center. Several strategies to be deployed as part of this project to improve water quality include treatment ponds and marshes, a denitrification trench, shoreline buffers, baffle boxes, pervious paving, and various underwater features. The total cost of this project is about $20 million. Next slide, please. Along with these capital projects, the city also will continue with ongoing non-capital initiatives. The development of a comprehensive stormwater master plan and the implementation of Green Street concepts for road projects as we move forward. Next slide. On the wastewater side, the city plans to invest $165 million. All of these are geared to minimize sanitary sewer overflows and the associated nutrient loads that come with those, and maximize the beneficial use of reclaimed water by using aquifer storage and recovery facilities to store water during the wet season, ready for use during the dry season. Next slide, please. Non-capital wastewater initiatives include the adoption of a formal CMOM program codifying practices already employed by the city, and the update of the city's fats, oil, and grease program. Fats, oil, and grease, as you know, build up in gravity sewer pipes and cause, are one of the leading causes of sanitary sewer overflows, and of course, disruption to service and all those kinds of things. With that, next slide. I really appreciate having the opportunity to present the information to you, and look forward to any questions that you may have. Thanks.
Thank you very much, Bill, for that very useful information. I'm going to move right into the next speaker. We're running just a little bit of ahead of schedule. So Isaac, if you need a little extra time, 3 or 4 minutes, please feel free to take it. And our next speaker does represent the town of Longboat Key. His name is Isaac Bowman, and Bowman. And I have a hard time identifying Isaac as a member of the town of Longboat Key team, because he was with Sarasota County for such a long time. He was part of that exodus a few years ago from Sarasota County to the town of Longboat Key, where they took a great deal of our talent. That's good, because they stayed in the area, and their good works are still benefiting the entireties of both Sarasota and Manatee counties. So Isaac is the director of the town of Longboat Key Public Works. I will turn it over to you, sir.
Thank you, sir, for that introduction. I very much appreciate it. Can everybody hear me okay? Good. All right. So again, thank you for inviting us to this workshop. The town appreciates having the opportunity to present some of the work we've been doing here as well. So a little bit of context. You heard a little bit earlier, but the town of Longboat Key, we were incorporated in 1955. We're a 10-mile long barrier island, and we are within both Manatee and Sarasota counties. We're bordered on the east by Sarasota Bay and on the west by the Gulf of Mexico, with New Pass and Longboat Pass inlets at our north and south boundaries, respectively. We have about 7,000 plus or minus permanent residents. During season, our population can peak out between 18 to 24,000. The median age on the island is about 71. We have about 218 businesses on the island, mostly hospitality, tourism related, some restaurants, and municipal government are the major sources of employment. The town of Longboat Key values a healthy Sarasota Bay and healthy Gulf of Mexico waters. As expressed early on, it contributes directly to the quality of life, the beaches and bays, and having a healthy lifestyle. It contributes directly to the property values and market economics here on the island. It contributes to the island atmosphere and the amenities. And anything we do on the island, to the extent possible, whether it's infrastructure or protective measures, are done in a fiscally responsible manner, value added and solution oriented. The town has adopted core expectations, one of which include the following. The town will protect the island's invaluable natural resources through best management practices and coordinated regional solutions for water quality, green building, irrigation, energy conservation, waste management, stormwater, and shoreline protection, which is another reason why we're here today. So a little more about the context of the town. You see in the right-hand picture, that's the barrier island that consists of the town of Longboat Key. We are essentially built out. What we see nowadays is primarily redevelopment. And any redevelopment that occurs, whether it's elevation, drainage, and water quality improvements, are to current code. The spine road that provides access to and from the island is Gulf of Mexico Drive. It is a state road, State Road 789. It is managed, owned, and operated by the Florida Department of Transportation. Roadside drainage systems on the public neighborhood roadways, the public ones, are owned and maintained by the town of Longboat Key, and there are some private roads within the island as well. The southern portion of the island was a larger master plan development type with some interconnected stormwater management facilities. The northern portion of the island was developed earlier, is older, is in has a lower elevation, generally does not have large master plan facilities, and is more susceptible to nuisance and structure flooding. The island is heavily vegetated and well landscaped and has quite a bit of open space for a developed barrier island. And we do conduct, we are involved in National Pollutant Discharge Elimination System annual reporting. We just completed our 5-year audit and we're waiting on the report that comes out of that. Some of the town's current codes and ordinances, there are performance standards for site development that include assuring drainage, flood prevention, and protection of water quality. Construction activities are required to minimize the amount of pollutants entering the stormwater system. And we do coordinate with the Southwest Florida Water Management District for permitting and water quality requirements for developments on the island. And town projects are required to meet the same code requirements. We have inspectors, we have a code enforcement officer, and our public works employees that keep eyes on activities on the island, both town activities and development activities and any other existing homeowner or condominium activities as well. The town also has a fertilizer management ordinance. It's pretty detailed. It includes the timing of application. It includes the content and application rate of the fertilizer, procedure for handling impervious surfaces. It does have fertilizer-free zones. It talks about the mode of application. It talks about exemptions, training and enforcement and penalty. An example of how that's handled annually, the town has a list of companies who do a lot of the fertilizer application on the island. Those companies are required to demonstrate that they've gone through the GMP training, produce proof to the town, a certificate. They get a decal on their vehicles, and we educate the residents to keep in mind to look for those fertilizer applicators that have gone through the town's training and certification process. Our code enforcement officer primarily oversees that and is involved in the education portion of our fertilizer management. So even though the town is highly developed, there is a high amount of open space, a high amount of vegetation, which helps with transpiration, and we are Barrier Island on sand, so we have very, very high perk rates. It's interesting, we get complaints from some of our older areas on roadways that don't really have a drainage system discharging into the canals, where a lot of the rainwater will sit on the side of the road. So from a nuisance flooding standpoint, people don't like that so much, but from a water quality standpoint, it eventually evaporates, it gets splashed back on the yard where it perks out. So it's an interesting dynamic there. The water quality surrounding Longboat Key is generally good, it's positive. Now we all experience when we have a prolonged red tide, none of us like that, we want to reduce those prolonged red tide events and such, but the water quality is good. This is why people come here. I'm going through canal dredge permitting, and one of the biggest problems I'm having is the amount of seagrass in the canals I'm having to mitigate. That's an interesting problem to have for a canal navigation program, but it's interesting that our canals actually are recruiting seagrass. We also will be and continue to work with the Sarasota Bay Estuary Program on additional projects in and around our Gulf and Bay waters to improve water quality or keep it in good shape. Just a couple of town projects we completed recently. Bayfront Park in 2017 includes a very well done low impact design and bioretention areas. If you have a chance, it'd be a great amenity to visit. And we just completed our fire station number 92, which also includes up-to-date water quality and flood control elements to current code. With that, I'd like to transition to the public works utilities, the wastewater system. The town centralized our water and wastewater utility system in the mid-70s. The town, we managed the water distribution and wastewater collection system on the island and somewhat off the island. But the potable water and wastewater treatment services are provided by Manatee County. We were very pleased to hear from Jeff the efforts they've taken on the Southwest Regional Treatment Facility. That's where all of the town's wastewater discharges to. Our wastewater collection system consists of 47 lift stations. We are fairly flat. We got to keep the wastewater moving. The wastewater is all collected to one master lift station. So we pay very close attention to this lift station. It's Master Lift Station B. Not that we don't pay attention to the others, but this one's very important to us. It pumps all the town's wastewater across and under Sarasota Bay. for a 2-mile stretch, then through an additional 1.5 miles across the mainland to the Manatee County Southwest Regional Reclamation Facility. Our average wastewater usage is about 1.7 million gallons per day, but as you all know, that can swing pretty dramatically at times, depending on how rainy the rainy season is. We are a mandatory evacuation area, so that helps after a storm, not having a lot of people still on the island contributing to the wastewater system while we make repairs and do what we need to do after the event. So in terms of the utility capital improvement program for wastewater, I appreciate the introduction earlier. I've been here about a little over 4 years, so I'm only going back those 4 years for information, but we put a lot of effort into upgrading and enhancing our infrastructure. Since then, myself and our utility manager, the town has spent about $640,000 in rehab of our utility lines. That includes inspection, cleaning, and lining. But we put and for a town, I know these numbers are a little smaller than some of the other entities you've seen, but this is actually a fair amount of dollar value for us. We put a lot of attention to our lift station rehabilitation. In the last 4 years, we spent about $1.2 million, including some efforts at lift station B. I'll show you some photos here in a little bit. About $156,000 in manhole repair, which is mainly manhole lining. Bypass pumps, we've spent $190,000 in bypass pumps, $82,000 in generators, and $150,000 in electrical panel upgrades to make sure our lift stations stay functioning as they should. In addition to all that, you may have heard about our subaqueous force main that I shared a little bit earlier. Before we had the leak incident last year, the town was already on a path forward, looking at options and opportunities for a redundant force main or a redundant path under Sarasota Bay, or a redundant method to get the wastewater off the island. And the town had already spent $750,000 on a feasibility study and actual permitting. And we are still in the actual permitting of that effort right now. So some examples of what I explained earlier, the rehab of the sewer lines, in the inspection, cleaning, and lining. I don't have a linear footage for you right now. The pictures on the right are an example of before and after. You see the groundwater and the rainwater coming into the line, and after it's lined, filling it up pretty good. Like I said, the lift station rehab, we've spent quite a bit of money. That's 16 of our 47 lift stations, about 30% or a third of our lift stations we've been able to upgrade and enhance and protect over the past 4 years, including lift station B, about 30 of our manholes, and 3 bypass pumps and 2 generators that we've purchased over the last 4 years. In addition to, in the next fiscal year, we're going to buy 3 additional bypass pumps to keep a permanent bypass at 3 of our more troublesome lift stations after storm events, and replace our major, one of our major lift station B generators. And those are the costs associated with that. As you heard from some of the presentations earlier, we also have a fat, oil, and grease program. We've seen very positive results. Typically, we know the areas that we need to focus on, certain providers. We know which lift stations have struggles with this. So what I'm getting at, we tend to see a lot of voluntary compliance when we talk to them about the situation we're seeing, and folks comply once we've had a chance to talk to them. All right, so this is an example of some work we did in our master lift station B last year. We performed a cleaning first of the lift station. The picture on the left is not pretty, and that's what we were running into. We spent about $252,000 to clean it, and also do some mainline cleaning and inspection of our 36-inch main line leading to this lift station. And the right-hand side is the after picture. That's after it's cleaned. You can see that our walls probably could have used some work. So that's what we did in 2021. Again, this is our master lift station where all our effluent pumps out. We did a lining project recently and completed that for $182,000, and that'll keep our lift station protected for some time. So as I mentioned, the town of Longboat Key is responsible for maintaining the wastewater collection system. All of our wastewater flows to master lift station B, which is about a third of the way from the north point of the island, pumped across Sarasota Bay under the location where those arrows are, to the Manatee County Southwest facility. And you can see in this older aerial photograph the arrow is pointing to where the line route is in Sarasota Bay. It's the line that actually goes from southwest to northeast. You can just see it in there. You can still see a star from that open cut years ago. And that's where our subaqueous force main runs till it hits the mainland. As you're probably aware, the town experienced a leak in that force main in June of 2020. It was on the mainland side of the route, about 400 feet north of Sarasota Bay. It was in a heavily vegetated portion of Longboat Point, an undeveloped area, in fact, part of their mangrove fringe area and wetland area. So there was no way to access it to repair without building some form of a haul road. And those are some of the photographs of the repair and the haul road that was built. And then on the bottom right, a little bit of the repair effort in the staging area. So like I said, on June 29th, the town and the Manatee County staff discovered a leak in our 20-inch buccal iron force main on the mainland side through Longboat Point, about 400 feet north of Sarasota Bay. We hired UT McKenzie and conducted that repair in about 30 hours. We built the haul road. Lift Station D had to be shut down twice midday to perform the repair. We did not have overflows in either case, although we were dealing with the situation on the mainland side in Longbar. And the force main was repaired on June 30th by about 5:30 p.m. We had hired ESA at the time to analyze Sarasota Bay for any migration of wastewater that may have made it to the bay. And the summary was that there was no evidence of even a short-term impact on the sewage leak on bacterial levels in Sarasota Bay, which we're very appreciative of and grateful of, but obviously this is not something the town wants to see ever. So we continue to take measures to avoid these types of situations. The town was required to execute a consent order with FDEP, and that was done in February of 2021. Those are just some photos of the repair effort itself. So the town continues to work on our subaqueous force main enhancement project and system preservation. As I mentioned earlier, we're in feasibility and permitting of a potential redundant force main under Sarasota Bay. That's already underway and under review. That was underway prior to the discovery of the leak. It's currently with the U.S. Army Corps and FDEP. We've gone through our first round of requests for additional information. We're waiting to see if we will be getting permits for that or if there's additional work that we need to do. We also are planning an assessment of our existing force main pipeline to take place this fiscal year. We're waiting to hear back from FDEP on some of our consent order responses to see before we move forward with that. If everything's in order from the DEP standpoint, we'll be moving forward with that. We're also exploring options for preservation of the existing portions of the force main along the mainland route. That's in progress right now to see what's feasible and what can be done here in the near term. And as I mentioned earlier, we do spend a great deal of attention on preserving and enhancing the existing system. That will continue, whether it's our island pipelines, our lift stations, our wet wells, the electrical systems, and adding to our generator and bypass pump inventory. This is just a snapshot of our 5-year wastewater CIP. I just highlighted some of those programmatic areas, the wet well and manhole repair, about 125,000 a year we're planning and programming. Rehab of sewer lines, about 200,000 a year. Our wastewater collection subaqueous, we have bookmarked 1.4 million in fiscal year 24 and 20 million in fiscal year 25. That's based on the best available data we have to date for the redundant, any sort of a redundant force main. Very recently, the town elected to increase utility rates to town residents and visitors, town residents, to be able to handle the upcoming infrastructure needs related to the subaqueous force main and some on the water side, but I wasn't going to share that today. And then again, the lift station rehab, our 5-year plan, about 200,000 a year to continue work on our lift stations. And just to conclude, I want to thank you again, but these photos show exactly why water quality is important to all of us. It contributes to all the areas I mentioned earlier. And thank you very much. I'm happy to answer questions at the appropriate time.
Thank you, Isaac. Excellent presentation. Frankly, I think all of the government officials did a superb job of not only staying on time, but actually addressing the serious issues, the difficult issues, and the issues that our communities need to address if we do want to improve water quality to the goals that Dr. Tomasco illustrated earlier in the presentation. So a lot of times when we're moderating these panels, we're searching and searching and searching for questions. That is not going to be the case this time. In fact, I have many, many more questions than we're going to have time to get to. So I'm going to need to prioritize them, and I will also be combining a couple of the questions to give all of the speakers an opportunity to address them. There's two questions that I don't want to ignore, but I want to postpone to speakers later in the afternoon. The first one has to do with the local governments addressing low, no, mow zones in the stormwater ponds that are in many of our neighborhoods, many thousands of them, in fact. And I believe it is at 1:30, we will have a Healthy Pond Collaborative presentation by Sandy Gilbert. I'm very familiar with his work and his presentation, and he will directly address the low, no, mow zones and the county's efforts on adopting ordinances that require some responsibilities for the subdivisions to care for those ponds in terms of nutrient reduction. We have heard a lot. There was a question about specific nutrient reduction efforts. This question came in very early, and I think most of the speakers have been very deliberate about describing their reduction activities. When we put together the community playbook for healthy waterways, we too face this issue and the need to both address and categorize both reduction, removal, and sustainability efforts. So with that, I'm going to move into what I think is probably one of the more difficult questions, and certainly one that we want to get to right off. And it has to do with the aging infrastructure and the necessity of taking some of these older wastewater treatment systems and converting them to AWT, which is, of course, advanced wastewater treatment, which specifically targets nutrients, and in this case, nitrogen, more specifically nitrates, which are the primary culprit in plant growth, including algae. I believe generally there's about 80 to 90% of nitrogen in all of our non-AWT reclaimed water that is in the form of nitrate. And this is, of course, the target that we want to get to improve that metric of water quality. So unfortunately, that infrastructure, or I should say the lack of performance of this infrastructure, has led to numerous discharges of wastewater, not untreated wastewater, but more specifically reclaimed water in both the City of Bradenton, who's not here to address, but also in Manatee County and Sarasota County. So Mike, Mylene, I'm going to pick on you first, if you don't mind, because you and I have just had this conversation a few days ago, and I know that you are prepared to address it. So can you please tell Sarasota County's ongoing work to address this initiative of advanced water treatment in the Bee Ridge plant, and the efforts to avoid this chronic problem of reclaimed water overflows into Philippi Creek? Mike?
Thank you. The Sarasota County is moving forward, as you mentioned, with converting the Bee Ridge plant to an AWT plant. That process is well underway. We should begin construction on the physical plant beginning right after the first of the year. In addition, one of the projects that the county is working on is constructing aquifer recharge wells at our Bee Ridge facilities, much like what Manatee County described as, we all have challenges during the summer months when we have excess reclaimed water, and sometimes it's very difficult to get rid of. So those aquifer recharge wells that we're constructing at the Bee Ridge facility will allow us to not only use our reclaimed water in a beneficial way by buffering or helping recharge our aquifers in this area, but it prevents those discharges that have been experienced because of the lack of capacity for storing that reclaimed water in Sarasota County. Just those two projects alone are in the neighborhood of $250 million for Sarasota.
And Mike, and I'm going to ask the same question to you, Jeff Goodwin, so if you can be prepared as well. Mike, do we have any way of estimating the amount of nitrogen that will be removed by going to the AWT treatment and upgrading the facility so that the discharges into Philippi Creek hopefully will be avoided in the future? One question specifically was, this is a lot of money to invest and nobody's questioning the investment, but will we be able to actually demonstrate through measurements the amount of nitrogen that will be removed from not entering the system?
Yeah, I don't have that number right off the top of my head, but it's a relatively simple calculation, because right now the Bee Ridge wastewater facility produces reclaimed water with a nitrogen content somewhere around 16 to 18 milligrams per liter. When the AWT project is completed, that nitrogen content of the reclaimed water will be less than 3. So on average, we produce, I'm going from memory here, so don't hold me to this number, but on average, we produce a little over 1 billion gallons of reclaimed water a year. So it's a matter of just doing that calculation. I don't have that in front of me.
Thank you, Mike. That's very helpful. And I would also add that later in the afternoon, you're going to hear some information about the nutrient loading from wastewater and the need to coordinate that fertilizer application to make sure that we are not adding fertilizer to compound the overnutrification that is created by wastewater. So it is unfortunately a very complicated formula. If I could,
excuse me, can I interject real quick?
Yes, please.
Our IFAS group has created a website for turf managers and community members that are interested, that they can go out and look at their individual property and see where the reclaimed water is coming from and see how much nitrogen is in that reclaimed water. When we explored this and took this out to a lot of our golf courses, they didn't realize that the amount of nitrogen that they're putting on their golf courses through reclaimed water almost mitigates what they need to put on for fertilizer. So that resource is available to not only professional turf managers, but the public as well.
Thank you, Mike. That actually was going to be another one of my questions later on. We might come back to it, but for now, Jeff, if you could give us an update on, again, the status of your centralized wastewater treatment facilities and the goal of reducing these anthropogenic nutrients into the surface waters as a result of reclaimed water getting away, if you would. I do understand, though, that in Manatee County, the nitrogen levels are significantly lower than in Sarasota County. But if you could address it, that would be very helpful.
Sure. So all 3 of our water reclamation facilities, since the big project at Southwestern, now MLE plants, which significantly reduce nitrogen levels from conventional advanced secondary treatment. So as I mentioned in my earlier presentation, when that went online, we saw an immediate improvement in nitrogen loadings from about 40%. We've since optimized that at that plant and made some improvements at our Southeast plant. and those numbers continue to improve. So between those two plants, we're less than 7.5 milligrams per liter of nitrogen that comes out as reclaimed water. Our north plant typically would perform in that manner, but in recent months we have struggled with some operational issues. Important to note, and I didn't mention this earlier, but we have no NPDES permits. In other words, we're not permitted to discharge to a surface body. We don't have an outfall. All of our reclaim either has to go into our distribution system for irrigation or into our deep injection well system. And I think I shared those numbers earlier. So we don't have a direct nutrient loading impact on surface body because of the lack of an outfall. And we'd like to see, and I'm interested in the later in the afternoon discussion, we'd like to see some data on some recent data on attenuation of nutrients when it goes out as reclaim. We feel like we've improved quite a bit in not just our water quality, but in the management of our reclaimed water. Whereas we're encouraging the users not to take more than what they actually need, and this, especially with our ag folks, we've seen a big improvement. So for us, with our nitrogen levels as low as they are and the lack of a surface water discharge, and we've resolved our I wouldn't say chronic, but we did have issues with unauthorized discharge of reclaimed water in years past. We resolved that with our deep injection well system. We feel like, unless the numbers could show otherwise, that in Manatee County, our efforts and money would be better well spent on resolving our stormwater issues. So that's been our message. Again, if the data starts to show that converting to AWT, we could have a significant impact beyond what we think we could, we would certainly recommend that to our board. Hopefully that helps answer the question from Manatee County's perspective.
Yes, Jeff, it does. And thank you very much for that. And I would like to add, I'm glad that this is all being recorded, especially the chat, because there's a great deal of useful information and links and responses that we're not going to be able to get to today that will be memorialized in these chats. So thank you for all the input from the participants and stormwater. And I don't want to let wastewater dominate this conversation, because stormwater is in fact a major contributor to our water woes here in our region. People like to categorize them as non-point sources of pollution versus the wastewater treatment plants, which are point source. I would argue that stormwater is also a point source of pollution, and every one of those points are all of our own backyards and our streets that we drive on. So there is a need really to focus on stormwater improvements. And maybe, Jeff, if you could give us a little bit of, and Isaac, I hate to cut you and Bill out of the centralized wastewater treatment. We might come back to you on this, but I do want to pivot to stormwater just a moment, Jeff. And can you tell me any plans or any ideas you're working on in Manatee County that will be improving the nutrient loading of stormwater into the Sarasota Bay watersheds?
Yeah, unfortunately, I have to defer to my colleague, Greg, if he's still on for the stormwater questions.
I should have done that, yes. Greg Blanchard?
Yes, so hello. Will you repeat your question, please?
Yes, Greg, I wanted to ask both Sarasota, Manatee, Longboat, and the municipalities what their individual governments are doing to address the nutrient loading from stormwater runoff into the Sarasota Bay watersheds.
Well, first of all, is our effort to pay attention to the older urban coastal watersheds. Work was needed in that area for many reasons, for stormwater structural and flood protection reasons, as well as environmental protection reasons. These areas were built before modern stormwater permitting occurred. FEMA regulations have changed since they were built. Everything was, I would describe it as out of date. It's a very large part of urban Manatee County that needs to be assessed in this way. So it's going one watershed at a time over a much longer period. I believe the structured approach is a very good one. The tools and information we have to do this kind of work today is vastly better than even the tools we had 20 years ago. I think ultimately it will pay very solid dividends as our programs are implemented. There's always a few surprises in the data, which I find personally interesting. And I'll just leave it at that. I don't want to drift too much off the topic of your question.
No, thank you, Greg. That's much appreciated. And I loved your little there about the surprises in the data. I think that speaks to many of the people on this call, because oftentimes we have preconceived ideas and conclusions, and then the data comes in and it doesn't exactly support what we thought we were, or does it? So maybe if I can shift to Amanda now. Amanda, we're looking for some of Sarasota County's efforts to improve the nutrient loading from stormwater. And maybe I also had another question here, if you find room to include it in your response, about some of the low impact design standards that are available, such as rain gardens, bioswales, and things like that. It would be helpful if we are considering those in our activities for stormwater management. So Amanda, you with us?
I am.
Wonderful.
Okay, so I guess first on your question on LID, we do have an LID manual, so those tools are available for use in Sarasota County. But what we're looking at further is how we can incentivize those to already built homes and developments. So if a resident wants to remove their concrete driveway and go back with pervious pavement, how can we encourage that, and what kind of impact will that have? As far as nutrient removal in stormwater, like I said, our biggest challenges is where do we accomplish these projects for nutrient removal, and our land is very limited. We're seeing some real potential with retrofitting the ponds. That has its challenges in the fact that, you know, we can't require historical ponds to go back and reconstruct. But we can make some progress with our own. The stream restorations, the natural processes that occur as the water flows through those systems, you have increased contact time with vegetation that removes those nutrients. And how much, I think that has yet to be determined. Studies have been done in other areas of the country, but not much here yet. So stay tuned.
Thank you, Amanda. I want to backtrack here just a little bit before I get into the next topic, and see if Bill Reeby or Isaac Bowman would like to add to the conversation of either the improved stormwater management or the aging infrastructure in terms of treating wastewater at a centralized facility. Isaac, I'll start with you, since you did talk about the most recent spill into Sarasota Bay. Maybe you can put some minds at ease that the piping system has been corrected, and that fortunately, hopefully, we will not be looking forward to spills of that nature in the future. And then after that, Bill, if there's something you'd like to add, please jump in, and stormwater considerations as well. I know that's a lot to ask, but I'm trying to get as much in as I can in the very limited time that we have. So Isaac, can I call on you to go first, please?
Sure, thank you. Yes, the town continues to proactively enhance our system. Like I said, we discovered that leak last year. We repaired it very quickly. The good news is when we cut that piece of pipe out, the part that had the issue, all the surrounding elements of the pipe was in very good condition. What we discovered is that portion of the pipe years ago was placed on some kind of a piece of wood or a log that was never removed. And that friction over the 50-year period contributed to that one rupture. The assessment we're doing this year is going to help us identify to make sure there's no other situations like that under the ground. We're going to do some electrical potential survey and some additional work to assess the pipeline. But overall, it's in actually fairly good condition. But we do monitor it very closely, and we're going to perform an assessment. Like I showed you in my presentation, the town does take our utility infrastructure seriously with the programmatic dollars being spent on rehabbing, upgrading the system. The good news for the town is in the past 4 to 5 years, we have spent a lot on enhancing our utility infrastructure to the point that our finance department said, slow down, you're spending too much too fast. It was simply a cash flow issue. But the point is, the town is very much invested in the utility infrastructure, and we're actively using those dollars to preserve and enhance the wastewater system. That's ongoing, and it continues to progress. On the stormwater side, we are also doing similarly as redevelopments occur, improving the method, the way the water comes off the property, areas to allow nutrients to drop out. Newer, larger redevelopments are already incorporating significant water quality and treatment systems because obviously they're looking to preserve the quality of life on the island as well, and incorporating some of those elements such as LID and others. And as I mentioned, we do have a lot of rapidly percolating sandy soils. So we do have a lot of runoff that just perks, I'm sorry, a lot of rainfall that just perks right out before it becomes runoff.
Thank you, Isaac. Bill Reeby, did you have something you would like to add to the conversation?
Yeah, real quickly on the stormwater side, as mentioned, we're going to put together a stormwater master plan. As you know, the city of Sarasota, we're built out. We're similar to Longboat Key, so a lot of it's reconstruction efforts and so on. So as part of the stormwater master plan, it's really looking at everything and then developing creative and cooperative ways, to further reduce nutrient loads and improve stormwater quality. So that'll be a big effort for us in the city, is that stormwater master plan. On the wastewater side, we completed a master plan in 2019. We shared that with the city commission. It's fully funded. So we know what we need to do. We know where our gaps are. And right now we're laser focused on executing that plan. So the whole idea is to minimize sanitary sewer overflows and continue producing really high level treated reclaimed water.
Thank you, Bill. And I would like to call to everyone's attention, this is not the last that you're going to hear about these innovative techniques and opportunities for both nutrient removal in stormwater and in wastewater. Dr. Collins has sessions in the afternoon that are going to go into greater detail on those. And I would also like to add that it's very clear that we're not going to get to all of the questions here. But we will address the questions that are in the chat that we're not going to get to specifically, such as the additional results from the Bowlees Creek study and composting aquatic weeds as a way of recycling nutrients. But I want to spend the last few minutes that together on a topic that continues to come up on virtually all of the government levels. And that has to do with these injection wells and these reclaimed wells. I guess, judging by the comments that I'm getting in the chat and over my text and in my email, as best as I can manage all three, there doesn't seem to be a high level of confidence that these reclaimed wells, these injection wells, are going to be reliable and that they are in fact contained and will be able to not impact our potable water systems. So let's see, who can I pick on first here? I think I'm going to go with Manatee County first on this one. And Jeff, I think that will probably fall into your camp. talk to us a little bit more about the confidence level in these injection wells and this method of disposing or storing of partially treated wastewater.
Well, in Manatee County's case, we're not injecting partially treated. We're injecting effluent quality into our injection well. So this is a very complex topic, and we have hydrogeologist consultants that we rely on for a lot of our information. But as far as the confidence that we have as an environmentally sound way to dispose of reclaimed water, Manatee County is very confident. We've had a deep injection well on Cortez Road online since 1988, and we have seen no indication of upward migration in that 30 years or so, and that continues to perform well for us. And the ones we've had constructed and permitted most recently, they demonstrate the same ability to keep the injected fluid in the zone that we're targeting. Where are those zones? It depends on the type of well, and so it's difficult to answer all the questions. But basically, what we're saying is we're injecting into a zone where the water quality is much poorer than the injectate, and we have great confidence that it's not going to move into the USDW. In the case of our class 5 at our North Plant, for example, it's well below the upper Floridan, and the confinement is there, and the safeguards that we're required to put in place through the permitting process. This is a rigorous permitting process that you have to go through with the UIC office, the Underground Injection Control Office from the FDEP, and you have to demonstrate throughout the entire drilling operation and thereafter that you can maintain confinement of that injectate. And if it was to migrate in a direction that it wasn't supposed to, the monitoring safeguards are in place would allow you to stop operation of the well so that the USDW would not be impacted. So lots of these across the state that have been in operation for a long time. The one here that I mentioned that Manatee County owns and operates, Tropicana has one. My colleagues on the workshop here operate wells, and I think they will say the same, that we have great confidence that this is an environmentally safe way to address our treated effluent, and it's certainly less impactful than discharging to a surface body, which really and truly is our only other option. And you're not going to be able to get rid of all of your reclaimed water through your distribution system, not in Florida, not in the summertime. So you have to have an option for the wet weather season. And again, in Manatee County, we're using our wells just for treated effluent at the moment.
Thank you, Jeff. Mike, I'm going to give you I'll give you the last word. And I'm going to switch gears here on you because I had one question that was asked several times, and it has to do with the septic tank replacement program. You talked about 50,000 plus tanks in Sarasota community, a $1 billion plus project. Can you give in a minute and a half some, I know, so I'm sorry. This is really fantastic because the questions are good and we can go on for hours and hours about this. But the final word will be yours, sir, addressing how we're going to prioritize these septic tanks in order to get the best return possible, because obviously we're not going to be spending $1 billion taking all 50,000 tanks off of line anytime soon.
That's correct. And one of the important things, and I know it's come up a lot of times in community discussions, is, my septic tank works just fine. Why am I putting it into a regional plant that's producing high nutrient effluent? And that's one of the reasons that Sarasota County is embarking on our plan to upgrade all of our treatment facilities to AWT standards to reduce the nutrients in our treatment facilities. You know, the Philippi Creek program took off about 10,000 septic tanks, and there's still additional tanks in the northern portion of our county. There's high concentrations of tanks in the southern portion of our county. I can't take off those tanks in the southern portion of the county until the upgrades are made at the Venice Gardens wastewater treatment plant, because I don't have the capacity to take that flow into the system. But as the upgrades are made to our treatment facilities, we will be looking at as you mentioned, the high impact areas, the areas where we can make the most impact at the least cost. This is not a cheap project, no matter what you do, but we want to maximize our efforts, and where we can find those high density areas, those are the areas where you get the best bang for your buck. And if those areas are the ones that are the closest to the bays, the closest to the tributaries, those provide the biggest bang for our dollars to improve water quality all along the bayfront.
Thank you, Mike. I really appreciate those comments. I apologize for running just 2 minutes over time, infringing on your lunch. I'm going to turn it back over to Dave, but I do want to have one closing comment. We've heard a lot about stormwater over here, and we've heard a lot about wastewater over here. And one of the common criticisms we hear of government over and over and over again is, why is this department not talking with this department? So my final word would be thank you all so much for your expertise, your input this afternoon, and we will continue to work on solutions, and we encourage improved communications between these two utilities within our local governments. And thank you all for joining us in the excellent questions. They will all be answered in the chat or in some other forum, possibly later this afternoon. So, Dr. Tomasco, it's all yours.
Thanks. I'm gonna make it real quick. I want to thank everyone, all the presenters. I want to thank John. You did just a stellar job. So appreciate it, John. For those of you who are not familiar with John, he's not only a really good person who's very good at these meetings, he's also a statewide expert on scrub jays, which a lot of people don't know. So very fascinating group of people we have here. I'm very proud of what we've done here, and thanks for all the speakers, and particular thanks to Darcy and to John. Hang in there for the afternoon. It's going to be a lot of information. A lot of the questions that we haven't addressed are going to be addressed in this afternoon session as well. So have a good lunch. Be back here at what, 1 o'clock, right?
All right. Hello, everyone, and welcome back to the Sarasota Bay Water Quality Restoration Workshop. We're getting ready here for our session 2, Innovative Approaches for Wastewater and Stormwater Management. I'd like to introduce our moderator for the afternoon sessions, Dr. Angela Collins. Angela is the Florida Sea Grant Agent in Manatee, Hillsborough, and Sarasota counties. Thanks, Angela, for taking the helm of our afternoon sessions. These sessions highlight projects that complement the utility and public works projects that we heard about this morning. These initiatives rely on the power of community and nature to reduce nutrient loads to Sarasota Bay. We at the Sarasota Bay Estuary Program believe that we need gray, green, and human infrastructure to steward a healthy bay. Each presenter will have 10 minutes because we have more presenters per session this afternoon. And there will be a 20-minute panel discussion and Q&A session following each set of presentations. Again, please enter your questions in the Q&A box, and we'll get to as many as we can in those 20-minute panel discussions following each session. I'll ask the panelists to please turn on their cameras. And Sandy Gilbert, I think you still need to accept the panelist invitation so that we can make sure that you can, oh no, you accepted it. Thank you very much, Sandy. Okay, with no further ado, here is Angela.
All right, thank you, Darcy. And thanks so much to the Sarasota Bay Estuary Program for putting on this really great workshop today. I think the morning session was incredibly informative. A quick recap of this morning, for those of you that weren't here, Darcy and Dave both provided a really good overview of why water quality in Sarasota Bay is such a big deal, not just for the environment itself, but also for the health and well-being of our area's residents and local economies, which are all intimately tied to a really healthy bay. There are lots of factors that influence this, and Dave kind of summarized why nutrients specifically are such an important variable to monitor and manage. So the morning session was a series of very informative presentations from local, county, and municipality managers that describe some of the ongoing and upcoming efforts and initiatives to reduce nutrient loads in Sarasota Bay, including but not limited to the government actions on wastewater treatment and stormwater management and existing infrastructure. So this afternoon, we're going to be focusing on more innovative approaches to manage these things that are not necessarily government driven. We're going to start out on the upstream side of things, specifically dealing with water before it enters the actual bay. And then after the break, the second session will focus on some in-water bay approaches that can help improve water quality conditions inside of Sarasota Bay. As Darcy said, I'd like to remind everybody to put your questions into the Q&A, and we'll be taking and addressing those questions at the end of all of the speaker presentations in each session this afternoon. Presenters, you will be limited to 10 minutes, and so I will be policing you, and if you start going too far over, I'll turn my camera on, and if it gets crazy, I'll just I'll interrupt you and kind of make you close out there with your closing comments. And then we hope to get to as many questions as we can during the Q&A at the end of each session. A quick reminder, this morning, we talked about being tough on the issues and not on the people, so that stays in place here. This is meant to be a really engaging discussion, but again, be gentle on the presenters, but don't be gentle on the actual issues that we're talking about. So with no further ado, I'm going to introduce our first speaker today, and that is Steve Swaw. He is with Progressive Water Resources. Steve's a civil engineer that has over 25 years of experience in Florida, and his specialty is water management and planning and water resources. He served as the executive director of Sarasota County's Planning and Development Services Business Center, and the chairman of the Sarasota County Stormwater Environmental Utility Advisory Committee. He's also served with the Sarasota County Environmentally Sensitive Lands Advisory Committee and the Sustainable Agriculture Policy Committee. He currently serves on the board of directors for the Florida House Institute for Sustainable Development. And Steve will be talking today about innovative approaches to nitrate removal. So take it away, Steve.
Okay, thanks. I'm going to try and share my screen. That is an old resume. A lot of those things are from another lifetime ago, I think. But be that as it may, let me to it. Are you able to see my screen?
Not yet. And just because you did it a lifetime ago doesn't mean it's not still valid.
Yeah, it just feels like a long time ago.
And Steve, if you have issues with presentation, we can do the same thing we've done for a few in the morning.
Yeah, understood. So it's up on my end. If it's not up on that end.
Right now we just see a blank screen. Oh, there you go. There, you're there. You got it.
Okay,
Steve.
great. So yes, my name is Steve Swaw. I'm a watershed manager. Going to be talking about some projects that we've been working on for nitrate removal. David asked that I initially touch on the nitrogen cycle for context. So to start, at 78% nitrogen, of course, is the most common element in the atmosphere. Like water, nitrogen can exist as a solid, liquid, or gas. And also, like the natural water cycle, there's a natural nitrogen cycle, where various bacteria can extract or fix the otherwise stable atmospheric nitrogen, process it for use by living organisms, and finally put it back in the atmosphere to complete the cycle. Nature's been doing this for eons, but healthy soil, typically characterized by containing organic carbon, is typically required to support these beneficial bacteria. These biological processes are how soil-based agriculture, like organic, access nitrogen without using conventional chemical fertilizer. So a couple things happened in the 20th century that changed the balance of nitrogen. The first was the ability to chemically extract the otherwise stable nitrogen from the atmosphere to produce synthetic fertilizer. This initiated the green revolution, but also had the unintended consequence of allowing agriculture to forego soil building practices because they can now just add chemical fertilizer. As a result, the amount of nitrogen in our soils and waters has been dramatically increased. So as we've been mining carbon from the earth and putting it in the atmosphere, in a similar way, we've been chemically mining nitrogen from the atmosphere and putting it on the earth. The second anthropogenic nitrogen producing contribution is human waste treatment processes, which while invaluable in cleaning water for human health considerations, does not always remove nitrate, as we heard this morning. Nitrate is bioavailable and instant food for plants and algae, including harmful algae like red tide. So I'll be presenting a few applications that use organic carbon media to remove nitrate through denitrification, thus completing the nitrogen cycle. The first application is a 550-acre golf course community located in Sarasota County. They receive reclaimed water where the total nitrogen averages about 85% nitrate. This reclaimed water is delivered to a designated storage pond. It's then repumped to irrigate the community, where if the nitrate fertilizer water is in excess of the fertilizer that's being applied, it can contribute to chronic algae problems in a lot of the stormwater lakes located downstream. So looking to reduce the nitrate at its local source, what was done is we installed what's called 2 subsurface denitrification systems consisting of 6 cubic yards each of a wood chip media material. They were put into the reclaimed water pond, into the bottom of it to create an anaerobic condition. These systems consist of gabion baskets filled with wood chips and an internal perforated PVC pipe system that is submerged. A pump is included to cycle the pond water through each of the systems, and it's estimated that approximately all the water in the pond is cycled once a month. This slide presents the reduction in total nitrogen influent and effluent concentrations in the reclaimed water pond over the period of 1 year. We just finished the first year of operation. And for reference, the red line is the magic AWT number, just for reference, of 3 milligrams per liter for nitrogen. This slide presents the resulting reduction in nitrate influent and effluent concentrations in the reclaimed water pond for the first year of operation. So in conclusion, we saw about a 49% reduction in total nitrogen concentrations and about a 74% reduction in nitrate concentrations for the first year of operation. I want to drop to the bottom there on return on investment. We look at this as a ratio between the cost of the project versus the amount of nitrogen removed. For the first year of operation, it's between $14 and $17 for nitrate and total nitrogen respectively. However, this media should last for many years, maybe even decades. And if we get up to 20 years, the return on investment would be under $1 per pound of nitrate and nitrogen reduced. The second example is Braden River Utilities. It is a private non-potable irrigation utility which services the 50 square mile Lakewood Ranch development in Manatee County. Irrigation sources include groundwater, surface water, water from the city of Sarasota and the city of Bradenton that meets AWT standards, and reclaimed water from Manatee County that does not currently meet AWT standards. So BRU, Braden River Utilities, with funding assistance from the Southwest Florida Water Management District, has implemented a passive nutrient reduction pilot project with the objective of reducing nitrogen and phosphorus concentrations in Manatee County's reclaimed water to meet AWT nutrient standards using various carbon medias. The project was constructed with 4 cells containing various organic carbon media configurations, as well as a header trench that also uses an organic carbon media for phosphorus reduction. Reclaimed water is delivered by overhead drip irrigation, and the flow to each of the cells can be individually controlled. Once the reclaimed water enters the system, it's essentially processed 24/7 by gravity using an operating head of about 4 feet before then it overflows into the adjacent pond that is used exclusively to store the reclaimed water before it's then repumped out for irrigation. These pictures show 2 of the cells, one of wood chips, one of sawdust. Like I said, we looked at several different medias and evaluating them, and the overhead irrigation drip system, as well as the final outflow control structure into the pond. The system was installed this summer and has been in operation for about 3 months. So far, then this slide presents a total nitrogen influent and effluent concentrations to date. For reference, the red line again denotes the AWT standard target for the project. And this graph presents the nitrate influent and outfluent concentration. So you see we're getting a pretty dramatic decrease in nitrate. In fact, we're getting about a 66 so far, a 66% average reduction in total nitrogen. Our target's about 59%, but we're getting about a 99% reduction in the nitrate concentrations at the system outfalls. So we're getting very good denitrification. For the first year of operation, we estimate a return on investment between $40 and $60. But again, this media should last for up to 20 years, which would put the return on investment between $2 and $3 per pound of nitrogen reduced. I should also touch on another type of organic carbon media, which is incorporated into the BRU project, but for phosphorus reduction. This is a charcoal type media produced by heating organic matter with limited oxygen. Originally discovered in the Amazon basin and referred to as terra preta, ancient civilizations presumably created it in the process of disposing of their waste or for heat generation, but it had another important benefit. It created a rich and sustainable soil that increased crop yields in otherwise poor soil environment. I've noted that a natural fire or controlled burn creates this type of media where there's limited oxygen at the flame base, thereby charring the pines and palmettos. It may be nature's way of adding carbon back into the soil. There's been an exponential growth in academic research to understand this process, primarily for use as a soil amendment, often referred to as biochar now. The media typically has significant water holding capacity and provides a haven for microbes and nutrients. We worked with the University of Florida and others to develop a unique organic carbon pellet to reduce phosphorus. Test results have indicated about an 80% reduction of phosphorus with a contact time between 15 and 30 minutes. We are now evaluating the total absorption capacity of the media. Couple last examples. This is Holly Farms, an existing client. It's a nursery located in Northwest Florida. In this application, an edge of farm denitrification trench of sand and sawdust was installed by the University of Florida to intercept and reduce the elevated nitrate levels, presumably from legacy fertilizer application. Based upon subsequent testing by the University of Florida, the system reduced nitrate by about 58%. University of Florida also estimated a conservative life of 15 years and a return on investment of 36 cents per pound of nitrate removed. So as nitrate is also the form of nitrogen released by on-site sewage, sewer and treatment disposal systems or septic tanks, these previous examples suggest that it could be a very cost-effective application to denitrify this potential nitrate, assuming that the local hydrogeology is not already providing it. So in this example, this is an area of septic tanks actually in Sarasota County, where it's all public right-of-way. There's a grassed area alongside the road, between the road and the canal, where one of these systems could be installed pretty cost-effectively, I think, to address any nitrate if it's a problem. So with that, I'd like to just acknowledge the folks that have worked with me over the last few years on these projects and continue to be partners. And thank you for allowing me to present.
Wonderful. Thank you so much, Steve. That was great, and you are right on time. Our next speaker is Dr. Mary Sfranek. She is with Wood, Environment and Infrastructure Solutions. Mary has extensive ecological and water quality assessment and restoration background, and has been working on water quality restoration projects for over the last 15 years, both in her current position with Wood, as well as in previous positions with the Florida Department of Environmental Protection, as well as the Southwest Florida Water Management District. She's recently been focusing her research to advance concepts in sediment biogeochemistry and groundwater connectivity with the goal of optimizing stream, wetland, and lake restoration project performance. And with that, I will hand the mic to you, Mary.
Thank you very much. I'm going to shut my camera off just so I can just going. All right, well, good afternoon. I'm Mary Sfranek, Principal Scientist with Wood's Water Resources Group. and we'll be talking to you about stream restoration for water quality improvements. This talk is a collaboration from our Wood Stream team, which is led by Dr. John Kiefer and includes a few other scientists and engineers in Florida. So I'm really excited to have the opportunity to talk briefly about urban channel renewal and our approaches to stream restoration in Florida and how it specifically applies to improving water quality. So for several canal systems and impaired streams in Florida, we've actually begun implementing Florida-specific stream restoration design techniques to convert altered and disturbed conveyances to become water quality treatment best management practices, or BMPs. This will actually become especially critical in highly urbanized areas such as the Sarasota Bay watershed that have basically run out of space to build large regional stormwater treatment systems. And stream restoration can be an incredibly powerful tool to help restore or re-restore, as Dave Tomasco called it, water quality in Sarasota Bay. So often in urban areas, streams are channelized as trapezoidal channels for flood control or stormwater conveyances. There are approximately 30,000 miles of urban streams or canals that are impaired in Florida. These urban stream systems often experience what is called the urban stream syndrome, using air quotes there. And due to largely impervious urban watershed, these streams actually experience flashy hydrographs or what is also called rapidly changing flows and levels, which cause scour, erosion, and deposition of the sediments downstream, which are typically loaded with nutrients. The canals actually have reduced floodplain function, reduced resiliency to any kind of flooding, reduced habitat and biodiversity in terms of fish and invertebrates. They have eroded surfaces that give way to increased and unbalanced sediment transport, and then increased nutrient loading due to low potential of nutrient attenuation. So urban channels are not really self-sustaining or self-maintaining as a natural stream as it was in the past before it was actually channelized or reconfigured. The figure on the left actually shows erosion, major erosion issues in Philippi Creek, such as unstable banks that cause erosion with bank failure and toe scour, which also, all of these things kind of lead to a massive sediment transport, as you see in the figure on the right, which is actually Mill Creek, and that's a little bit extreme, which is blocking off an entire culvert. And these eroded sediments are depositing under bridge culverts, and this is a very common scene in many, many places in Florida, especially urbanized areas. So we do have a few variations of bank stabilization approaches. I'm not calling it stream restoration. These are bank stabilization approaches, which include hard armoring. That's the figure on the far left. And that actually could protect the banks from shear stress or high velocities, which, those actually contribute to erosion. And they're usually using hard gray materials, such as concrete, riprap, or gabion basket walls, which is what you're seeing in that figure, the terraced gabion basket walls. Yes, it does stabilize banks, but it does not provide any additional ecological benefits. Bank slope reduction, the figure in the middle, actually reduces gravitational forces. And that's really important because then that could reduce some of the bank failures by adding some of the vegetation, some shrubs and trees, which also reduce shear stresses and erosion. The added vegetation could provide a little bit of water quality and habitat and aesthetic benefits. It looks a little bit more natural and better than the hard armoring version on the left. However, we do prefer, and we're biased, with natural stream restoration, so natural channel design is NCD, because of the added benefits for not only water quality, which is the topic of today's workshop, but also habitat and flood mitigation, fisheries, sea level rise, resiliency, you name it. There's a ton of different benefits, which I'll talk about in a little bit. I think I went too far. Okay. So if we're somewhat constricted on workable space, then we can actually fit a multi-stage channel into the footprint of the canal. This will allow a creation or reconnection of a natural floodplain. So right now you're looking at just a channelized canal system. This is what our typical canals look like. A lot of issues, trees falling in and whatnot. And that'll actually reduce velocities, shear stress, scour, and provide additional treatment in pockets of wetlands if you do reconnect that floodplain. So this is actually what a typical would look like after restoration, where you have multi-stage channels here. And if there's room, so this is a canal being restored back to a multi-stage channel. However, if you have room to do natural channel design where you can add the meanders and pools and riffles, then that would actually provide more sediment deposition and reduce nutrient loading through the hyporheic exchange from groundwater base flow into the channel. All right. So stream restoration designs, this is going to get a little more technical, are highly prescriptive, but there are several items that need to be considered. So it's often possible to fit a natural stream and floodplain, which is critical, within the footprint of an urban channel. But it's really important also to make sure that the site has the right conditions. So that has a lot to do with space, speed of water, and things like that. So based on the site conditions and dimensions, we need to assess whether the stream will have sufficient power. So what is the power? It's being defined by this figure here. Do we have enough slope and drainage area to contribute to that? So these are basically different components of types of streams that actually fall into either a wetland slough, a natural channel, or a gully. Can it be restored back to a natural channel? In addition to that, is there sufficient room to fit a meandering floodplain within the right-of-way? So if we have this similar situation, you have a canal here, a very nice large park, or any kind of a right-of-way, county right-of-way, whatever it may be. Do we have space? Typically, we need at least a minimum of 100 feet, but it really depends on a lot of other components. So we have to modify that number. And are there other existing utilities or structures that can reduce the available working area? We have to work around that. So that always does drive cost up here and there, and there's bridges in the way as well. So we do actually have to use an integrated surface groundwater modeling to provide reasonable assurance that the stream flow rates, the frequency of the flows, and upland seepage components are actually going to provide a functioning stream. And that's how we actually match the scale of the solution to that the problem. So this is just an example of a conceptual project that we provided for a stream restoration, what we call Eco Park, at a county-owned parcel, the one I just showed you a moment ago, a different view. And this actually is showing sufficient right-of-way. So they have a lot of room. We're very excited about this site to support natural channel design and other things like low-impact design features that Steve was talking about, adding different, having LID projects with a rain garden there. You may add some kind of carbon-based, golden gold or BAM, the bioabsorptive media. Those things work fantastic, especially when stormwater is flowing through that to improve water quality before it makes it into the actual stream here. So this eco park can actually be enhanced with trails, benches, improved native habitat. Right now we just have a grassed field, educational signage talking about the different ecological components that are going to be enhanced. Impervious parking is also a thing. This area here is just a potential area that could be used with limited right of way, but this is about as good as it gets in terms of space. Now I want to talk about some benefits. This is really related to water quality, since there are so many benefits. It would take a whole nother probably day to talk about all of them. So the water quality benefits from stream restoration, they're actually largely due, and I'm about to get a little nerdy here, kind of falling behind perfect coattails of Steve before me. So biogeochemical mechanisms, they're actually the main reason that stream restoration works. So the biogeochemical mechanisms, they actually include a modification of the metabolic dynamics, such as gross primary productivity, the same thing also called photosynthesis, ecosystem respiration, that actually is like the engine that drives nitrogen reduction. So Dr. A.J. Reisinger from University of Florida and his coworkers actually just found in a recent study that there's a significant restoration effect on nutrient uptake rates. So important. This study was so important with restored reaches as compared to non-restored, having faster uptake velocities, which really just means that the nitrate gets taken up faster across all different seasons. So that's important in Florida because we basically have one season, right? We don't have a solid winter in the summer. So this is actually really important because it turns up the throttle of that engine of the stream's internal natural attenuation capacity to remove nitrogen loads, not just move them downstream, they're removing them out of the system. Keep that in mind. Sometimes we're moving things in different places, but we're not removing them. Due to urbanization, natural carbon sources from the watershed are reduced. And as you just heard from Steve, which was a perfect lineup for me, carbon is actually the essential element that is necessary for nitrogen removal. via nitrification and denitrification. We need both of those. Stream restoration can actually enhance the autochthonous productivity, which all that means is that the carbon is actually created within the stream, so inside of the stream. And then that kickstarts the nitrogen assimilation by modifying riparian canopy cover, adding in different carbon sources such as woody herbaceous debris, in-stream aquatic vegetation, submerged aquatic vegetation. Adding all those components in there can play a major role in improving water quality downstream, which is not the only benefit of stream restoration, I will say. But what I'm trying to make a point here is that these canals that we're looking at every day do not have any of these components inside of them, which means we don't get any nitrogen removal. So again, I'm going to come back to hyporheic exchange I mentioned earlier. It's a big term, but it is really all it's talking about is groundwater, superficial groundwater seepage. And it is a major substantial fraction of nitrogen entering the stream laterally that we kind of forget about. And that actually is impacted by nitrogen sources such as fertilizer, septic, wastewater facility, effluent, maybe by reclaimed water or other application methods such as a spray field or a rapid infiltration basin. So stream restoration actually can attenuate the nitrogen seeping in from groundwater base flows, which is a huge component, not only the stormwater part of it, and then to a considerable extent. So I really think that groundwater is an important part of the overall water quality discussion for Sarasota Bay, and it should be actively addressed right alongside stormwater as a nutrient source. And in addition to that, stream restoration can be a great recommendation for watershed management plans or alternatives analysis because of the different benefits for water quality, flood protection, enhanced habitat in fisheries, and resiliency to sea level rise. Because a lot of times we're dealing with the tide. So we have been recommending and providing designs for stream restoration based on water quality issues for Sarasota, Manatee counties, for Philippi, Alligator, Bowlees, and most recently Pure Strain Gap Creek to reduce these nutrient loads and to reduce overall operation and maintenance needs and costs, which is a big component when you're looking at budgets. So just going to summarize here that canals can be renewed back into a more natural and highly functioning inline water quality treatment system, and not just a water conveyance to reduce flooding. We can actually use them to not just get rid of water. Stream restoration projects can actually provide multiple benefits, and they provide a connection to nature back to the community. This is a new community amenity here that's going to basically take a depressed area and make it amazing. And it's just a really great project. So these communities are going to be more connected to these urban ecological environments. And as long as we're dealing with the conditions that account for the potential limiting factors. So stream restoration design projects can be tailored to maximize nutrient load reduction and even can provide water quality credits to reduce allocations from basin management action plans. Didn't get a lot of time to talk about that, but you could get credit for your project. So just want to say thanks to SBEP. Appreciate being able to talk about something so exciting, such a cool restoration tool that can help re-restore Sarasota Bay.
Excellent. Thank you, Dr. Sranik. Our next speaker is Sandy Gilbert from Solutions to Avoid Red Tide, also known as START. Sandy is the current CEO of this organization. It's a nonprofit organization that was founded in '96. And he does a lot to secure funding to reduce excess nutrients in our coastal waters and increase public awareness about the importance of preserving our marine environment. So Sandy, I'll go ahead and toss the mic to you.
Hello?
We got you. There you go.
Okay, thanks. START has been around since 1995, working to reduce the excess nutrients in our waterways that feed red tide and other harmful algal blooms. In recent years, with our involvement in the development of the playbook for healthy waterways and the realization that stormwater is now the source of 65% of the nitrogen in Sarasota Bay, we began focusing on dealing with stormwater. You were looking at the Bay Park next to Van Wezel Performing Arts Hall with Progressive Water Resources 600-foot long denitrification trench that is already buried under the ground and filtering the excess nutrients in the stormwater from this 53-acre site. Adding to this natural filtration process, START will bring our Shuck and Save oyster recycling program and a clam seeding program with the Sarasota Bay Watch to the Parks Lagoon to further filter the stormwater along with fostering seagrass growth. When completed, this unique system will filter 72 million gallons of stormwater before it runs into Sarasota Bay. Our greatest impact so far in dealing with stormwater has been our work with local community stormwater ponds. There are over 6,000 of them in Sarasota County alone, and most of them are operating at only 40 to 60% efficiency in removing excess nutrients from the water before it leaves the pond and heads downstream. Thanks to a grant from the Gulf Coast Community Foundation and a working relationship with Sarasota County's NEST program, we've been able to assist a dozen local neighborhoods with advice on how to properly manage their stormwater ponds and to provide some funding to help cover the cost of the aquatic plants necessary for a successful pond enhancement program. Some of the communities that we have worked with on their ponds include Rivendell, the Meadows, and the Bird Rookery at the Venice Audubon Society, where Molly Holland of the NEST program orchestrated an outstanding event with 120 volunteers who planted 3,000 square feet of plants on a Saturday morning in May. With another grant from Ed Childs and Elizabeth Moore, START worked to create another pond enhancement program for communities in Manatee County. You were looking at the Whisper Bend Pond project before the enhancement began, and now the pond after completion. Quite a functional and aesthetic improvement. We expect to complete at least a half dozen pond enhancements in Manatee County this year. All this pond enhancement activity led to a number of collaborative activities with different partners, which in turn led to our application and ultimate acceptance for a major $250,000 three-year grant from the Charles and Marjorie Barancic Foundation. We are now known as the Healthy Pond Collaborative, and the partners are START, the Sarasota County NEST program, the University of Florida IFAS Sarasota Extension, and the Science and Environmental Council of Southwest Florida. Over the course of 3 years, the distribution of the Barancic Foundation funding will be 70% directly to local neighborhoods to buy aquatic plants to enhance pond performance, 9% to develop public educational materials, 11% to hire an intern in year 2 to help monitor our pond projects and to follow up with community residents, and 10% for administration and monitoring supplies. While many communities contact us for help because they're troubled that their ponds look like this, there are some that are divided on using best pond practices over either aesthetic reasons or perceived high maintenance costs. This, ladies and gentlemen, is the enemy. What many people falsely believe is the way a stormwater pond should look. Or as one proud golfer once remarked, they look just like the ponds at the Masters. Well, what's wrong? The pond is mowed right down to the bank, and it has no aquatic plants growing in the shallow water on the littoral shelf. Why is that bad? Without a no-mow zone or taller grass around the bank of the pond, like you see here, that is at least 8 inches to 12 inches high and at least 3 feet wide, lawnmowers will ride over the bank, causing damage and erosion, weakening the bank, and reducing the pond's ability to hold stormwater as it fills in with added soil. In addition, the absence of aquatic plants on the littoral shelf will allow more wind-borne waves to break against the bank and also cause erosion. The aquatic plants also absorb nutrients and fertilizer from nearby lawns and help block out sunlight that curtails unsightly algal growth. We then show questioning residents the evolutionary result of ponds that do not have at least some protection from erosion within mow zone. and planted littoral shelves. The first phase of decline is the arrival of unsightly algal blooms from the excess nutrients in the eroded soil, and then the appearance of deeply eroded banks that may need costly remediation. In fact, at the end of the day, most questioning residents are ultimately won over to using healthy pond practices on the basis of money. As shown here, there is generally no cost from lawn service companies for letting your grass grow taller around the pond. And to add aquatic plants on the littoral zone is now only running about $1.50 to $2 a linear foot. In contrast, the cost of remediation or repairing the pond's bank is considerable, now running about $60 to $80 per linear foot for the geotube process and $100 to $200 a linear foot for the more advanced GeoWeb process that you are looking at. We have worked with several neighborhoods who were late to react to pond problems and are now spending over $1 million to upgrade their ponds. The message is clear: spend a little now or a lot more later. I'm sure many of you are wondering why I haven't talked more about the role ponds play in the overall environment, and especially as important habitat for wildlife. Well, that's because we were advised by some very experienced hands at getting healthy pond practices approved by HOA boards to focus on the money angle. Once that is done, then we bring in the other aesthetic and wildlife elements as added benefits. We also add the well-appreciated fact that the real estate community tells us that a house on an attractive, well-functioning stormwater pond is worth 20% more in property value than the same house on an unattractive pond. And lastly, what about results in terms of improved water quality after a pond enhancement program? We are working on getting more comparative data from our future pond projects, but we do have some promising preliminary results from one neighborhood that in just 20 months after a pond enhancement program achieved the following: 50% improvement in water clarity, 51% reduction in chlorophyll, 32% reduction in phosphorus, and 22% reduction in nitrogen. While we need more results over time to accurately determine the impact pond enhancements are having on water quality, it certainly looks like we are on the right track to make a measurable difference. Thank you for your attention, and I would only ask any neighborhood community that would like to contact the Healthy Pond Collaborative for a consultation on your stormwater pond, please contact me by email at sandem133@aol.com. That's SANDEM133. Thank you all very much.
Wonderful. Thank you so much, Sandy. The speakers are all doing such an awesome job at keeping on time. Our next speaker is Dr. Abby Tierna. Abby is with the University of Florida IFAS Extension Office in Sarasota County, and she has been working on multiple water resource issues in Florida since she started this position over 5 years ago. Her PhD research focused on quantifying changes to wetland hydro patterns as a result of human disturbance, which makes her well suited to some of the discussions she will be taking part with today. She's responsible for creating a lot of education and outreach programs, as well as public volunteer opportunities for various water resource issues. And her topic today is going to be optimizing the use of reclaimed water. And I will go ahead and pass it to you, Abby.
Thank you, Dr. Collins. It's so nice to be here. And while optimizing the use of, I'm not sure what she said, that's awesome. I like to just call it bay-friendly fertilizing. So let's talk about bay-friendly fertilizing. So I'm going to talk to you about bay-friendly fertilizing with particular emphasis on reclaimed water, and then talking about fertilizer in your irrigation water, which is via reclaimed water. And then finally, what are some tools that you can use to help you become more bay friendly in your fertilizing efforts? So first, I'd like to ask this question. I don't expect you to actually put in the poll the answer. I'm sorry, put in the chat the answer to this poll. But I just want you to look at pictures A and B, and I want you to answer this question internally. Which bay would you prefer to live around and recreate in? And this might seem like a silly question, but it's actually an important question, because while we're all sitting here, we know we want to live and recreate in the bay that is represented in picture B. What I often see in my work is that there's a great disconnect between what we want and what we're willing to do to make it happen. And so I'm hoping that the tools that I provide for you today make it easy to give us this picture B. It'll just be one piece of the puzzle, one step in the direction of making sure that our bay continues to look like B and doesn't look like A. So first, let me talk to you about what is reclaimed water. So reclaimed water, actually, I'm going to go back before I get into the technical part, helps us preserve high quality drinking water by providing us with a reliable and economical alternative to irrigation water. So it's really important resource, and reclaimed water is also known, has lots of other words associated with it. Something like reclaimed water is recycled water or reused water. It's definitely former domestic wastewater that has been disinfected and treated to remove solids and certain impurities. So let's look at that process. So thank you to Mike Milet for developing this for the Water Quality Summit back in 2019. He shows that the process of wastewater treatment right here is a 7-step process, 8 steps if you include biosolids, which we won't talk about today. But from the collection to biological treatment, clarification, filtration, and then ultimately disinfection before it is stored and then distributed for the sole purpose of using it as irrigation water. And I'll get more into that. So as,
hey,
yeah.
Abby, can you move your mic just a tiny bit away from your mouth?
It's too loud, I'm sorry.
No, you're good. It's just a little bit of echo.
Oh, thank you for letting me know. Is that better?
Yeah.
All right, cool. As Mr. Milet mentioned today, Sarasota County government is planning to upgrade all of its treatment facilities to advanced wastewater treatment for the sole purpose of removing nitrogen and phosphorus. But until that work is done, the work that I'm about to present is important. So how is reclaimed water used? Well, this is a pie chart given to us by the Florida Department of Environmental Protection. And first, before I get into how it's used, we must recognize that Florida is a national leader in water reuse. Approximately 738 million gallons, or 44% of the total domestic wastewater flow to the state, is used as reclaimed water and for beneficial purposes. And that was in 2015. That number has grown to 1.5 billion gallons per day that is used as reclaimed water. And historically, that water, reclaimed water, has been used largely in public access areas. And then there are other parts of the water that go to other uses, but most of it goes to public access areas. What is growing is actual use in private lawns. And so I'm going to mostly focus on that. So here's an example of a public access area. And this is a baseball field. So before I get into the tool that I have to present to you, I want to talk to you a little bit about what is in your reclaimed water as far as fertilizer. So thank you to Sarasota County Government Utilities for providing us not only with the funding, but with the data to do this work. And so what you can see here is the total nitrogen that is available in the water reclamation facilities reclaimed water from the Bee Ridge facility, the Central County facility, and the Venice Gardens facility. And so each line is associated with one of those reclamation facilities. And what you can see is that there is some great fluctuations in the amount of total nitrogen that comes from those plants to the distribution system, and then eventually out to golf courses and yards and play fields, etc. As Dr. Dave Tomasco mentioned, perhaps the most important nitrogen species is the dissolved form, the dissolved inorganic form. And so while this chart talks to you about total nitrogen as a whole, it includes both the inorganic and the organic forms. So we have done work to figure out how much of this total nitrogen is actually in that inorganic form, also known as, well, one of its forms is nitrate. And so my question to you, and again, you don't have to put the answer in the chat or anything, I just want you to stop and think, on average, what percentage of the total nitrogen that I just showed you coming out of those Bee Ridge, Venice Gardens, and Central County water reclamation facilities is in a form that's available to plants. So readily available to plants means that it's in that nitrate form, that inorganic dissolved form. What percentage do you think that is? Do you think it's 30 to 55% of the total nitrogen is in that readily usable form, or between 80 and 90%? Give you a minute to think about that. So if you said between 80 and 90%, then you're right. So a large majority of that total nitrogen that I just showed you from those water reclamation facilities are actually available to plants immediately. And so that is an important point, because that means that it's actual fertilizer. So it's the same type of species of nitrogen that we put in fertilizer in order to make it available to plants immediately. So that might get you wondering, well, so if there's fertilizer in my water, how much is already in it, and do I need to apply any more fertilizer? So that might lead you to ask, how much nitrogen fertilizer does your lawn actually need? Well, there's some great research done by University of Florida turf scientists that tell us for our region, it is recommended that you amend your soils with anywhere between 1 and 6 pounds of nitrogen per 1,000 square foot per year. So that's per year. And so you can see that's really dependent on your turf type, but it's also dependent on your soils, which is also really important to recognize. So while the range is between maybe 1 and 3 or 4 and 6, depending on your turf type, you also have to consider your soils. So how much nitrogen fertilizer has already been applied if you have reclaimed water? So we did a little case study just to show that if you apply 1 inch of irrigation water per week per 1,000 square feet at this point of the year, as of October 1st, you have already put down 3.2 or 3.3 pounds of nitrogen per 1,000 square foot. And remember, 90% of that, or around 3 pounds, is readily available. It is the fertilizer. It's readily available to plants. So that's coming out of Bee Ridge. In Venice, it's 3.1, and then in Central, it's 1.5. And so you might then ask yourself, well, do I get reclaimed water, and how do I know where I get it from? Well, thanks to Sarasota County government and their great GIS team, they put together this wonderful GIS map that showcases where each water reclamation facility, where their use area is, and also we put on top of that our recommendation at UF-IFAS Extension in Sarasota, whether or not you should be needing additional fertilizer based on what I showed you as what is recommended by turf scientists, or whether or not you need to fertilize with caution. And I'm going to share with you the 2 tools that you can go to this tool. You can click on it. You can actually put your address in to see if you get reclaimed water and whether or not where that reclaimed water comes from. So you can determine whether or not you need to fertilize or fertilize with caution. So that's a lot of information if you use reclaimed water and you are a homeowner. We also have information if you use reclaimed water and you are a golf course manager. And then we also have information if you don't use reclaimed water, but you need to know how to fertilize using a bay-friendly approach. And so this is a fertilizer calculator that was created by my assistant, Jackie Lebowitz, who did a wonderful job. And you can see here that I selected, where does my reclaimed water come from? I don't have reclaimed water. So it doesn't matter, but I water once a week. My lawn size is 928 square feet. I want to know that if I use a fertilizer that has 16% nitrogen, and let me show you what that looks like on the bag. There's usually 3 numbers on your fertilizer bag that correspond to nitrogen, phosphorus, and potassium. And if I use a bag that looks like that, and I want to fertilize twice a year, I have this bag, but I don't even know how much of the bag I need to put down. I don't know how much I should put in my spreader, because that's really difficult to determine, in my opinion, when you're going out to try to make sure that you have green leaf blades and healthy, robust roots. What do I need to do? And so this tool helps you figure out that given that you want to fertilize twice a year, you only actually need to use a half a bag to get down 1.86 pounds per event, which will lead you to your no more than 4 pounds per year. Please note that Sarasota County has a fertilizer ordinance, and we can give you more information on that fertilizer ordinance, which says that you have to use at least 50% slow release nitrogen, which you can see in my little caption here, that the guaranteed analysis helps you to understand if you have 16% total nitrogen, 8% of that has to be slow release, which you can see the polymer coated urea is an example of that slow release nitrogen. So the tools that you can use to help you understand how to be a bit better bay-friendly fertilizer, or use bay-friendly fertilizing techniques, is to go to bit.ly/bay-friendly-fertilizing_home. And then if you're a golf course superintendent, we also help you with your needs, and that's bit.ly/bay-friendly-fertilizing_golf. So you can visit those 2 tools in order to get all the information that I shared with you today. We also have videos that help you walk through the tool. If you have any questions, you can reach me at my email, atern@ufl.edu. And I do want to say right before my time is up, that we also did a little study looking at how much nitrogen, total nitrogen, and that dissolved in organic form of nitrogen is actually moving onto people's lawns. So we collected quite a few samples out of people's sprinklers. Shout out to anybody who's on this, who let us come to their home and collect samples. And what we found was variable, but certainly we found fertilizer in their water to be at rates that were useful for fertilizer, and to be at rates that this tool is even more needed than we expected, because there's still high levels coming out of your actual sprinkler. So you might be thinking that there's some losses and changes, and certainly there are as it moves from the distribution system to your pond or to your actual sprinkler system, but there is still enough of that dissolved inorganic nitrogen that is a fertilizer in your water. If you have any questions, I'll be happy to take them at the end. Thank you.
Awesome job. Okay, now we are to our question and answer session. So I'd like to ask all of the panelists to please go ahead and turn on your cameras, and we can sort of have a group discussion here. And then I'd like to remind the audience to please put any additional questions that you might have for any of the speakers that we just heard into the Q&A or into the chat, and we will do our best to answer them appropriately. So a lot of the questions that were in the Q&A have already been sort of answered already, but we've got a couple extras that we can discuss now. And I think this first one is probably directed more toward Dr. Turna and Sandy regarding, sort of our educational messaging. So we heard in that morning session that the counties are really only able to manage a very small percentage of the stormwater ponds in the region, right? And a lot of those stormwater ponds fall under the jurisdictions of private landowners or HOAs. And so what are the best ways to get this message across to our private citizens and the people in charge of managing these ponds, and, getting that economic impact information out there, as well as the ecosystem implications of healthy ponds?
Abby, you guys, can you hear me?
Yes, we can.
Well, Abby, why don't you go ahead, then I'll follow.
Could you repeat the question?
Sure. What do you think are the best ways to get the educational messaging out to the general public regarding how to manage ponds appropriately? That just because there's so many that are out there.
There are so many. That is a great question, and we're still looking for that answer. We go HOA by HOA, and then we also do webinars and workshops, and we table at events. And I can tell you that we're still only hitting a small percentage of the individuals who live near or around an actual stormwater pond. So we were hoping that there would be some social diffusion of information as we talk to HOA leaders, but it's been an uphill battle. I think that people really need to challenge their perception of what makes a healthy pond. A lot of people like to use the word pristine when they don't see anything in their pond, which is really interesting because I never usually say my pool is pristine. It's just, clean with chemicals. And I definitely don't want that to be the way my environment is clean with chemicals. So it's an uphill battle, but I think Sandy's hitting the nail on the head with his economic message. So I'll let him take it from there.
Well, there's that, but also part of the Healthy Pond Collaborative is for Abby and Molly Holland and Jennifer Schaefer to work on a much needed pond manual that will be given to HOA leaders that'll give them a step-by-step. This is how you take care of your pond. And because of the fact that we're tied into IFAS, that will go up online and literally be available through their system all over the state. So that's one of the more exciting things about the Pond Collaborative. Yes, we're going to involve a lot of local people on site, hands-on. This is how you can fix your pond, but there's going to be a manual that's going to get, I think, pretty wide distribution on 1, 2, 3, how to do it. So that's what Abby was alluding to. That's what we're trying to correct with this collaborative.
Yeah, those partnerships seem to be so key because this is not just a local issue. It's obviously a Florida-wide problem. This is another question about landscapers and how willing they might be to adopt new approaches or comply with the techniques that are already in place. And because homeowners really often don't know whether or not the landscapers are doing the right thing, they just assume that they are. So I maybe just throw that to the group and see what the general consensus is on how well landscapers are in compliance on some of these recommendations and regulations.
I can make a quick answer. One, any property manager, any landscaper, any pond maintenance company can do what we want. One of the problems is they don't, because they get complaints from neighbors and they want to keep the business. And if the board of the HOA isn't on top of what a healthy pond is and how it should be managed, it won't be managed properly. And because the pond company, they know, but they don't want to lose the business because they let the grass grow too tall and Mrs. Smith is on them, and the next thing you know, the board is on them. So that's my comment. And one other thing about the grass and the tall barrier around the ponds, we had a lady who very nicely interviewed 14 pond and landscaping companies in Sarasota County to see would they charge more for leaving the grass tall and not mowing it with a lawnmower, but mowing it with a hedge trimmer or a weed whacker. And an answer was, out of 14, only one would charge more money, and it was slight. So that's part of our pitch. It isn't going to cost you money. It's just you got to get used to what to do.
Okay, Great. This next question is for Steve, and it's about septic systems, whether they can be adapted for better water quality, the existing septic systems that are already in place.
Okay, so septic systems like wastewater treatment plants are not all created equal. They can be a real source of nitrate. They're designed like a treatment plant in many ways to process nitrogen to the point of nitrate and release it. But what a wastewater treatment plant does to go to AWT is to add denitrification to get rid of the nitrate. There are ways to design a septic tank, or even if it has to be replaced, to install a septic tank so that it basically is a AWT septic tank. It includes a denitrification system. As a matter of fact, the state of Florida, the Florida Health Department has developed some of the best research I've ever seen on this topic. They've looked at it. They looked at it for multiple years. Damon Anderson out of Tampa was the lead researcher. It's published on their website, and it's now required, I believe, up in the Springs area through the legislature passed what's called, I think, the Florida Aquifer and Springs Protection Act in 2016. And so any septic tanks put in up in that area where nitrate can travel and persist as this dissolved inorganic nitrogen form, the septic tanks have to put in a denitrification system, which is basically an organic media under the drain field in the water table. So that could be done. It may be a lot cheaper than hooking everyone up to septic. That's a real expensive proposition. And some counties have adopted that criteria. I think Broward County adopted it, so it could be adopted. I think I've seen from the health department, they have records of how many septic tanks are replaced a year. I think in Sarasota County, conservatively, it's probably 5%. So in 20 years, theoretically, if they were all retrofitted when they were replaced with advanced wastewater treatment, if you will, you could have solved the problem that way. And then I think the denitrification barrier as a last resort, if it is a problem, can also solve it. The last thing I'll say, in this area, the hydrogeology may be unique enough where we're getting natural denitrification between the septic tank and the waterway if the distance is long enough. And there's a carbon source in the water table. You'll have denitrification bacteria. I've looked a lot of the water quality data in Sarasota County, and it appears to indicate that that may be happening in our area. But you know, not all septic tanks are created equal. Depends on the hydrogeology, and just like wastewater treatment plants are not all the same.
Okay, great. And we have time for one more question, and then our break starts at 2:05. And this last question I'm going to toss to Mary about the natural stream restorations. The question was whether how much maintenance is involved with them through time, or do they become self-sustaining?
I just answered that one, but I can answer it here as well. So yeah, they are designed, the ones that we design are designed to be self-maintaining and self-sustaining, so should reduce operation and maintenance requirements dramatically compared to what canal maintenance would require in terms of dredging and, you know, bank stabilization, either hard armoring it or continually adding vegetation back. So depending, it's really based on the flow and velocity rates within the system and the slope of the actual valley. So additional things of revetments, if there's really flashy systems and high flow rate swings, then we can add additional, like at the toe, additional things will be put in there to reduce erosion in the future. So it really just depends on a lot of different factors that I went over. But it definitely should reduce O&M tremendously. That's a big perk for doing stream restoration.
Okay, well, thank you so much to all of the speakers in this session. It was incredibly informative. We are now on a 10-minute break. We're going to join back here at 2:15. So a huge round of applause virtually for everyone who spoke, and we will see you all back here in about 10 minutes. Dave, I think we'll put the timer on so that we know how much time we have left. So welcome back. I hope you all have refilled your coffee and you're ready to get into our final session for the day. So our last session was about some of the upstream and more land-based approaches. And now we're moving downstream into the saltier water, back in my comfort zone as a sea grant agent. So we're going to be talking a little bit about some of the in-water innovative approaches to water quality improvement in this session. Our first speaker is Dr. Jay Lavaroni. Jay is the staff scientist for the Sarasota Bay Estuary Program. He has been with Sarasota Bay Estuary Program for quite some time. Before that, he was with Moat Marine Laboratory as a research scientist. He has turned his attention recently to restoring local shellfish populations inside of Sarasota Bay, particularly scallops and oysters, and his recent focus work as a scientist with SBEP has been the development of numeric nutrient criteria, a monitoring strategy for tidal creeks, as well as restoration of artificial reef and oyster habitats throughout Sarasota Bay, in addition to other habitat restoration initiatives that he's been working on. So I am going to toss the mic to Jay if you're ready, and you can share your screen, and we will get started with the last session of today's workshop.
Thank you, Angie. Good afternoon, everybody, and thank you for the opportunity to present today. Let me see if I can get this thing started here. Okay, does everybody see my screen and hear me okay?
Yeah, your mic's a little loud, but otherwise you're good.
Okay, I'll turn it down. Well, got a lot to talk about, little time to talk about it. So let me get right into it. I'll be talking about oyster and artificial reef restoration in Sarasota Bay. These are just two types of habitats that the estuary program is involved with its partners in restoring habitats throughout our watershed. These are in-water habitat projects. Ironically, this is in-water approaches to water quality improvement, and I'm going to tell you up front that these particular projects do not actually focus or prioritize water quality improvements. They are primarily habitat projects, although I will admit that there are some opportunities to learn about the potential for not just this work, but other work that'll follow in the following talks, to discuss the potential for water quality improvements. And so hopefully we'll have a nice discussion about that at the end of all of our talks. So again, I'm going to focus on two types of habitats, Sarasota, say oysters and artificial reefs. I'll be looking at the history of oyster populations and reef programs in our area, the need and the interest in doing restoration and what those restoration projects have shown us. So I'm going to start with the Sarasota Bay oysters. How many oysters are in Sarasota Bay? Where are they located? Well, we have two programs that provide us with the data and information as to the location and the amount of oysters throughout our watershed. The first one comes from Sarasota County and the work that Kathy Moe and Mike Jones did years ago, looking at oyster distribution, the types of oysters, the types of oyster habitat throughout the tributaries to the county waters. And the map on the left shows the different tributaries that they looked at. The one on the right gives an example of the work done in South Creek, where they had 3 different stations, upstream, downstream, and a middle station where they did a whole slew of oyster biometrics, size, percent live, percent dead, spat. So they generated a lot of useful information on the amount of on the oyster populations within the Sarasota County waters of our watershed. Subsequently, another really good data set is from the Southwest Florida Water Management District seagrass mapping program that we use to set water quality targets. Actually, back in 2016, they were able to start providing information on oyster habitat throughout the region, including Sarasota Bay. And these maps show you what those look like in our 3 lower bays, Roberts, Little Sarasota Bay, and Blackburn Bay. I know it's not very difficult. It's maybe a little difficult to see, but the oysters are in orange. And in the Roberts Bay section, I put a couple circles around areas where oysters are the dominant habitat type. From this information, we get an idea as to the extent of the oyster acreage, if you will, in our watershed. And if you look at the bottom line there, where we have totals in both hectares and acres, you can see that now these were two different not studies, but 2 different data sets with different regional scope. But we have anywhere from 50 to almost 80 acres of oysters in our bays, and so we're doing really quite well. However, back in 2005, I think it was, the estuary program was interested in doing oyster restoration in the bay, and I was still at Marine Laboratory, but I worked with Gary Wallerson in the program to look at the potential for oyster restoration. Our approach was to look at historical distributions, look at existing distributions in the bay, and review water quality data, and look at the health and status of certain habitats for their evaluation for restoration. We came up from that and subsequent work to, I'm going to focus on 3 different locations where we have subsequently conducted oyster habitat restoration. The first one was down at White Beach in Little Sarasota Bay. Shortly thereafter, we went up to Longboat Point and constructed oyster habitat up there. And finally, in 2017, with FWC, we created some oyster habitat at the mouth of what was be the 34th Street Stormwater Viaduct that runs into Sarasota Bay. I would like to say that this work was a partnership with a lot of folks, and I do want to give a nod to Reef Innovations down in centrally located in Sarasota. Not only did they help us with our oyster restoration work, they also were instrumental in getting us involved in our artificial reef work as well. So it does take a lot of work to get the shell, to transport it to the site, to construct the reef modules, to transport them, and ultimately deploy them at the oyster reefs. This is a Google Earth image of the reefs that we created at Longboat Point in 2016. At the top, you can see 5 little semicircles there. I don't know if I can use my my pointer, but these 5 circles, they were 50 feet in diameter. Little did we know that just to the south, these are natural oyster and mangrove habitats just to the south of where we constructed ours. And if you look at 2021, 5 years later, those reefs are looking very good, the ones that we created at Longboat Point. Here are some photographs of those that were taken this last year, showing that we do have the ability to create oyster habitat. It's a pretty tried and true method, and just a matter of finding additional opportunities to do that. Here's one last slide on the oyster reefs that were created at 34th Street with FWC. We monitored those reefs every year. 2018 was the first year out, and they looked really good. In 2019, don't know if it was related to the red tide or not, but we saw a decline in the number of oysters, the size of the oysters, and the density of oysters on those reefs. We couldn't go out last year because of COVID restrictions, but this year when Corey Anderson and I went out, we saw that the reefs were in fact doing quite well. As you can see on the graph on the right, the size frequency distribution, we've got oysters that are up and over 3 inches in length out there, and they're doing quite well. So we're really happy with that work. Now, quickly, I'm going to turn to the artificial reef program. Both Sarasota and Manatee counties have excellent artificial reef programs that they manage and maintain every year. Their focus has been primarily on their offshore reefs for obvious reasons, for diving and fishing opportunities, but our interest with both counties was the bay reefs. In the left-hand Sarasota County map, you can't see very well, but I'll be focusing on some of the reefs, Walker Reef and Hart Reef and Sports Fisherman's Reef in Sarasota Bay, and subsequently in Manatee County waters, there's 3 reefs called Bayshore Reefs and Whale Key that we were interested in supplementing them with reef materials. Artificial reef management programs have developed over the years. We don't just throw any materials of opportunity out there anymore. We have been looking at specific habitat modules that we would like to deploy that would focus on the habitat, providing habitat for target fish species. In this case, we were interested in providing habitat for juvenile gag groupers. The module in the middle, the deep cover, was the one of the most interest because we've shown that those things are attractive for those types of fish. We deployed in Sarasota County waters in 2014 and Manatee County waters in 2017. In 2018, we hired Aptum, who does the reef monitoring for Manatee County as well, to monitor our reefs. They did 2 types of visual diving surveys and 1 baited underwater camera survey to look at the utilization of our reefs. in Sarasota Bay. These are the Sarasota County reefs that had been soaking for 4 years. Real quickly, just want to show you one of the results from one of the reefs. We were able to do 3 reef surveys under this grant from FWC. Again, we had a serious red tide in 2018, so we couldn't really get any effective information in 2019 or 2020. When COVID came, there were also restrictions as well. So we only have 3 surveys to date on those reefs. But this one in particular at Walker's Reef, especially if you look at the deep covers and the results of the fish utilization of those deep covers, they did find that they were being used by gag groupers. In fact, in this one particular case, they were chock full of gag groupers. So we do know that they are optimal habitats for grouper. We are interested in continuing this surveying once this most recent red tide has finally abated and our populations return to what we would consider normal for Sarasota Bay, and we will continue to determine whether these reefs are providing habitat for not just gag grouper but other reef type fishes. So with that, I would just like to summarize what are the implications for water quality, because as I mentioned at the beginning, I haven't really discussed that. These projects were specifically designed to create habitat or to restore habitats. We did not pursue them as water quality improvement projects. Our monitoring results did not report or suggest that any water quality improvements were met as a result of the successful implementation of these projects. Now, there have been other folks and in water projects that have been promoted and designed for water quality benefits, and I think we'll hear about those, subsequent to my presentation. What I would like to hear, what I have seen is that very few of them have actually done any empirical investigations. In fact, there's one that I know of done in Tampa Bay by Bruce Barber with the Gulf Shellfish Institute that looked at the benefits of regional shellfish work on water quality improvements. So I'm looking forward to hearing about those opportunities subsequent to this talk. So my cautionary tale would be that we have to be careful with our expectations for promoting these types of projects. I'm talking about oyster, and I'm not talking about other shellfish species, but they do fall into the same type of organism as a oyster, that we have to be careful about our expectations for promoting these as benefiting water quality. But nonetheless, they are clearly worthwhile toward restoring habitats, getting public engagement, and other benefits to those types of programs. So with that, I will turn it back over to Angela and look forward to the question and answer period. Thank you.
Great. Thank you so much, Jay. Our next speaker is Dr. Randy Edwards, who is an independent scientist. He's a retired research professor from University of South Florida and also scientist with the U.S. Geological Survey Center for Coastal and Watershed Studies in St. Pete previously. His experience and expertise is in marine and estuarine ecology, with emphasis on the biology and ecology of fishes and the importance of habitat specifically to those fishes. So with that, Dr. Edwards will be talking to us today about fishery habitat enhancement of seawall environments. And I'll go ahead and toss the mic to you, Randy.
Great. Can you hear me now? Great. I am Dr. Randy Edwards. Good afternoon. I am a marine ecologist with almost 50 years of professional experience, including almost a decade and a half at Mote Marine Lab, as Angela said, followed by almost another decade at the University of South Florida and U.S. Geological Survey. I've been a member of the Sarasota Bay Estuary Program Technical Advisory Committee from the inception of the NEP in 1989. One of my main areas, as Angela said again, is research. My main areas of research focus has been on fish ecology, particularly with regard to fish habitats. I am now retired. Saying that, I want you to understand that I have and will have absolutely no professional or financial self-interest what I will be discussing today. I will not be involved in any aspect of what may go forward except to be available to offer suggestions based on my experience. It's a labor of love strictly. Next, over my lifetime, bays and estuaries in Florida, like Sarasota Bay, have been greatly altered, impacted, and in many cases, ecologically degraded by man-made changes that are often called development. Probably the greatest of these impacts has been the dredging and filling of huge areas of natural shoreline habitats in creating seawalled canals and waterfront properties. Natural shorelines like those lost to development are enormously ecologically important and productive, particularly as nursery areas for juvenile fish species. I don't know where the slide's going forward, but that's, can we back up a bit here? Probably the greatest of these impacts has been the dredging and filling of these habitats for waterfront properties. Sarasota Bay, now, next slide, please, has close to 100 miles of seawalls. Here are some of the seawalls in Sarasota Bay. Huge areas of altered shoreline and seawalls exist in other Florida bays and estuaries. Here's a quick tour. Next slide. This is Tampa Bay. Next slide. Tampa Bay again. Next slide, please. Tampa Bay. This is, again, go forward. One slide, please. Tampa Bay, this is on near where I live on Manatee River. Next slide, please. Here we have Charlotte Harbor, huge areas. Indian River Lagoon. Next slide, please. And finally, Broward County, where I grew up as a young boy. The same situation exists in Palm Beach, Dade, Monroe, and Collier counties. There are over 1,000 miles, probably much more, of seawalls in southern Florida. Next slide. That's why I say it is in our hands. There is something we can do. It is in our hands. With that huge potential in mind, 30 years ago, while a scientist at Moat, I was awarded a small Sarasota Bay National Estuary Program Early Action Demonstration Project directed toward developing a way to recover at least part of the habitat value lost when all these natural shorelines were filled and seawalled. Because of time constraints, I will be only able to give you a general description of the project, which consisted of designing, constructing, installing, monitoring, and evaluating with regard to their habitat value artificial structures along seawalls in a finger-fill canal residential development, Country Club Shores on the southern end of Longboat Key. Next slide, please. 4 replicates of 4 different designs of what we call seawall reefs were installed in the Country Club Shores Canal. All 4 designs were found to be effective, but one design stood out for its effectiveness, cost, and ease of installation. Next slide, please. Generally, I can describe that design as a standalone wedge-shaped volume abutting the seawall, fabricated from standard PVC pipe, and the wedge consisted of numerous pipe members connected at various angles that resulted in a complex series of enclosed spaces of many sizes and shapes that could be used as habitat by young fish at various stages of age and growth. The cost of the materials for such structures could be as low as $50 to $75 when purchased in bulk quantities today. Next slide. This wedge shape was used in order to maximize volume of the structure and its footprint on the bottom without any impacts to boating along the canals. This is a scale model drawing. After the modules had been installed for 9 months to allow for growth of fouling organisms, the modules were monitored by making underwater counts of fish present at the structures and along 50-foot lengths of bare seawall as control sites. Next slide, please. It is not, next slide again, zoom in. It is not an exaggeration to say that the results were spectacular. 200 to over 300 fish were observed at each module, whereas no more than occasionally 1 or 2 fish, usually 0 fish, were seen at the Bears seawall control sites. After the study concluded, the Sarasota Bay National Estuary Program expressed interest in moving forward, but was inhibited by from immediate action by lack of permitting approval from the FDER. I was a soft-funded scientist in Moat, and the Moat administration was unwilling to provide any funding for the concept. The concept then simply withered on the vine. But you know, even a valuable fruit that is withered on the vine can have viable seeds that yield much more fruit. My vision for the concept is as follows. Because the program has so much potential value to other estuary programs and to bays and estuaries throughout southern Florida, I have suggested that Sarasota Bay take the lead in developing a collaborative project with the other Florida estuary programs. Next slide, please. The estuary programs would develop a project that would scientifically develop, further test, and refine implementation of the concept with test sites in all the estuaries. The programs would then, because the concept has so much value to other areas as those counties that I mentioned, would be in strong position to obtain EPA funding for the project. In addition, local, for example, counties and cities and regional water management districts and such could provide small but significant matching for a well-funded, well-designed project. The collaboration should also include significant participation from the Florida Fish and Wildlife Commission, perhaps for fish monitoring, and from Florida DEP for permitting considerations, and both might be able to contribute some funding because of the importance of the project to their primary missions. If that kind of collaborative program cannot be developed initially, I suggest that at least a start should be made through the Sarasota Bay Estuary Program, perhaps with funding from local sources and regional sources, such as counties and Southwest Florida Water Management District. Further funding could be obtained from federal sources like the National Fish and Wildlife Foundation, for which such a project would be a perfect fit. If, however, nothing is done along these lines, the results will not just be that the large opportunity for this environmental enhancement will be lost, but it will likely result in furthering what is happening now, with various entities promoting and selling scientifically untested and unproven, proven enhancement products, that may be not only be ineffective, but in some cases detrimental, but that also falsely convince the public that enhancement is being attained and thus taking away the public attention and advocacy for real environmental improvement. Having now made this presentation, the ball is now in the Sarasota Bay Estuary Program's court. Please don't drop it, Dave. By that I mean, I intend to not promote, initiate, or lead any further efforts on the matter. I will, of course, as mentioned previously, be always willing to freely help in any way requested. Next slide. Thank you for your consideration.
Thank you so much, Randy. Our next speaker is Damon Moore from Manatee County Parks and Natural Resources Department. He is with the Ecological and Marine Resources Division, where he has worked for over 10 years. His work involves funding, designing, and implementing environmental restoration and habitat creation projects. He does this while engaging community partners from school children and local volunteers to academic researchers, government agencies, and nonprofit organizations. Damon is going to talk a little bit about the work in the Manatee River, previously known as the Oyster River, a little bit about oyster restoration in the Manatee River. Take it away, Damon.
So thanks so much for having me. Again, I'm going to talk about some exciting work that we've kind of prototyped and piloted and have really big plans to move forward with in the future. So just real quick about me, I am a restoration practitioner. I work here for Manatee County government. I manage a small division in the Ecological and Marine Resources, called Ecological and Marine Resources in our Parks and Natural Resources Department. I have been doing this kind of work for about 20 years, half of that in the private sector, in the past 10 years with Manatee County government, and I am making the leap back to private sector. I'm starting with Environmental Science Associates in November. So I'm looking forward to doing a lot of this kind of work here in our area moving ahead. So about this talk in particular, this is going to focus on the Manatee River, which as Angela mentioned before, this was formerly called the Oyster River a long time ago. But I'd like to just kind of remind everybody that this is kind of a story of oyster degradation. And every time you look into the history of any of our coastal areas, you're going to find a very similar story to any of the creeks along Sarasota Bay. But I mean, it's a worldwide phenomenon. I mean, overall, the world has lost 85% of its original oyster population. So a lot of what I've kind of dug up in the history and looking at opportunities is going to apply to a lot of different areas. This is like looking into this stuff, there's some really cool history on all these things. So I'll just kind of get into it. One thing I always try to bring up with this discussion of oysters in particular is that there's the issue of shifting baseline syndrome that certainly applies to this. This is one of those things where, you know, I grew up here in Manatee County. My grandparents were from here, and it's always, well, I remember back when it was so good. But the issue with oysters in particular is the impacts for these were done so long ago that nobody's grandmother or grandfather was around to talk about how good it was back then, because this particular resource was impacted a long time ago. So that's really important to keep in mind with any of these marine restoration opportunities, that sort of stuff. So basically what I did when looking into this project is I just started digging back as far as I could find any references to Manatee County and oysters. So some of the earliest one I got back was 1793, the Fulch letter, where this is talking about what the Indians called Talachakpu and the Spaniards called River of Oysters on account of the many of these which blocked its entrance. So me looking for justification for, you know, the restoration of this resource, that's a pretty good clue. Then looking back through the earliest map I could find with that had reference to like more or less recognizable landforms in this area is the 1837 map by John Lee Williams, which in the area where, you know, referencing where Manatee River is, they're calling it the Oyster River, and you see where the Braden River comes back down here to the south there. So another really good clue that, you know, there's certainly justification in doing this. Getting into a little bit more detail on written documents, this one from 1898 talks about an 1876 voyage that was taken here by Smeltz. The important thing here is he notes basically everywhere in Southwest Florida is kind of noted here. So he kind of calls out everybody, but he says in 1876, he came to the West Coast in one of the largest oyster growing areas he could see. Notes oysters everywhere. And then the next line after that is like, how little did I think that in less than 25 years, every one of these bars would be partially or totally depleted. So that was an interesting thing to me, because I was really looking to find what could I use to verify that and even try to look more locally. So I fell into this trap where you can digitally search through the Library of Congress. Most of the old newspapers in the country have been digitized, and you can search by this. So it's a rabbit hole, but it's a lot of fun. So I started putting in search terms like palmasola, like oysters, things that were locally relevant to this area, and was able to draw out these articles from, you know, the late 1800s. This one in particular was heavy shipments of oysters are being made from Palmasola. Palmasola is on toward Tampa Bay on the west end of the Manatee River. This is another one. This is basically the predecessor of Noah here, but Mr. Rouge was an oysterman up in the Panhandle around Apalachicola area, but even here in this, dated 1897, this is all of America, and Florida especially, with the experience of past by profit, is destroying her natural wealth in every direction. And they also make reference in the same document to canneries built in Apalachicola, and says recently a plant on the Manatee River at Gulf City. This turned out to be the Little Manatee River when I looked into it differently. But growing up in this area, I had no idea that there was ever a commercial operation of oysters in this area. It's just another one of these older things like that talks that out. But this one really caught my attention because it very specifically calls out us folks here in Manatee County. So this is from 1900, and this says, oyster culture should receive large attention by property owners in the waters of Manatee County. The natural beds have been destroyed, and for several years the supply must be very limited. So I started to take this personal. And as you keep digging who this I got from the Manatee County Library, I'd always heard that, like, oh, underneath the streets you'll find oyster shells, and most people say, well, yeah, those came from midden mounds, and they would just take them and underlay the road. And I'd always heard that was the truth. But when I came across this, I always wondered, like, if you have an aggregate material right by the river where you're developing this new growing city, you would have that material available there. So this kind of confirmed it. This is John Glazier. This is one of the pioneer families in this area, but noted that was Manatee Avenue, the main road through town here, was paved with live oyster shells, which were taken from the river. And I thought, well, maybe they meant like fossilized shells or just shells that were laying around there. But then he went on to note that Manatee Avenue was then the most odoriferous street in the whole United States. So kind of confirming that was from live oysters that they were hauling up to pave roads with. So a lot of physical impacts to this resource. This is one of the other ones. We've talked a lot about water quality and treatment of sewage and that sort of thing. I found on one of these other maps, this one dated 1922, this little pink box down towards, this is just to the east of Manatee Memorial Hospital. But when I zoom right in here, this says Imhoff Tank. And I'd always wondered, I'd seen this strange structure that had gone to, it was a dance floor. Everybody had a story for what this thing was. So finally I found this, I looked it up, and this was a very rudimentary sewage treatment facility that was there. But like, as this town was growing, we started, sewage treatment was very rudimentary for a very long time. That wouldn't have been good for our oyster population. I then looked through these are severance records for mining shell off the bottom of the river in Manatee. So this particular company called Bradenton Dredging and Shell Company, these are the records that was self-reported from 1931 on through 1962. The main thing to look at here is this is the reported production in cubic yards. The total for this one company that operated out of here was 651,253.5 cubic yards of material that would have been good culture material for oyster spat to settle on and start growing, was then removed up and then used for various industry. And then another big issue there is, like, we altered the hydrology of the area by creation of the Lake Manatee dam there. It serves as a wonderful drinking water supply for a lot of people, but this changed the salinity regimes in the river, so that sweet spot where the salinities are appropriate for the predator-prey relationships for oysters to thrive would have shifted somewhere in the river there. Between this and then just changing land uses and the pulses of fresh water coming in. So we've done a lot of things to work against oysters. So in looking at that, we tried to find, like, if we're looking at this in terms of what are good opportunities to regenerate this, we started looking around, we see, like, we have areas where oysters are growing in the river. So we don't appear to be limited by the spat. If there's hard material out there, the oysters are growing on them, and any shopping cart that gets thrown in the river and stays there for a year gets a bunch of oysters. Not advocating that's the way we do it, but we started surveying these areas. We find these little remnant oyster bars all around there, and then we'll find they're always on these, like, really nice shallow banks. Intertidal, we've actually found some oyster populations. Jay and I went out into the river and dove it in some places and found some good areas of subtidal oysters in the river as well. But looking at good areas of opportunity, there's a lot of these. This is just like, keep this image in mind as I switch to the next slide. So this is at I-75 when you cross the bridge going over to like right before the exit for 301. There's a lot of these areas. So this area in the yellow circle is what was in the last slide. You see this same signature is all throughout the Manatee River. These are areas from like basically downtown towards I-75 and a little bit west of that, where this seems to be currently basically a sweet spot for oyster restoration. The salinities are good there. The other thing that's really important in terms of kind of the reality of permitting it is this area is very low in seagrass growth, because we wouldn't want to just restore one good aquatic habitat for another one. So the feasibility of this is pretty strong. So this is really hard for me to do in 10 minutes, so I try to just kind of motor mouth through it. But one thing I did want to note is, you know, a lot of these areas we have piloted and done prototyping projects. This picture is one that we did in Robinson Preserve a couple of years ago, and very similar to the results that Jay talked about in his presentation, where if we reintroduce the culch there, these things are ready to grow, ready to give all these ecosystem services that they provide. So with that, I'll wrap it up. Thank you very much for listening.
Thanks, Damon. That was amazing. You're getting a lot of feedback in the chat. And our next speaker, we're moving on to a different bivalve now. We're moving on from oysters to clams. And this next presentation is sort of a team presentation. Bethany Loya will be presenting. She is with the Diatom Initiative. And also part of the team is our Kurt Hemmel, who's the president of Gulf Shellfish Institute and also the owner and operator of Bay Shellfish Company, which is a hatchery here in Manatee County, and Ed Childs, who is the instigator and founder of the All Clams on Deck initiative. So with that, I'm going to go ahead and let Bethany introduce her talk, which will be discussing potential clam and seagrass restoration efforts inside of Sarasota Bay. And Bethany, if you're there, just share your screen and turn on your camera.
Okay, just one moment. It looks like I need to make Bethany a panelist. I will do that right now.
And for those of you out there in virtual world, if you have any questions you want to tap into the chat or the Q&A, please feel free.
Thank you so much. Can everybody hear me okay? Let's go ahead and share my screen. How is that? Is that good?
We don't see your screen yet.
Okay, let's see here.
There you go.
Thank you so much. As Angela said before, my name is Bethany, and I have a graduate degree in sustainability from the University of South Florida. I was recently brought on as a managing director of the Diatom Initiative. I work with Kurt Hemmel, also the proprietor of Bay Shellfish Co. It's, if you don't know, it's the oldest bivalve hatchery in the Southeast, engaged in commercial production, research, restoration efforts over the last 25 years. I'm here to talk about two organizations that we hope will offer contributions to marine water quality throughout Florida, both with groups currently focused on the area in Tampa Bay to Naples. The creation of the Diatom Initiative won, and it was spawned by Bay Shellfish after years of involvement with bivalve restoration and research, and the other group is called All Clams on Deck. Kurt and I were asked to fill in for Ed Childs, who was unable to present his work done here, but that group is called All Clams on Deck. So before diving into specifics, I would like to give a brief historical perspective of the people and groups involved. As many folks know, Ed has been a lifelong conservationist, prominent figure in our local economy and environment, someone who incorporates sustainability wherever possible and comes from a family tied to public service. Kurt Hemmel is the proprietor of Bay Shellfish, which worked with a broad diversity of organizations, including private and nonprofits, leading universities, local, state, and federal government. That work has ranged from engineering systems to providing bivalves for research and restoration for decades. And Ed and Kurt came together years ago and created something called the Gulf Shellfish Institute to address research needs for shellfish farmers as well as environmental concerns. And so, as you can see, they have a pretty obvious overlap. Individually, both Ed and Kurt have initiated organizations to work towards solutions, needing problems to be solved that we can see kind of obviously by our, the damaging of our nearshore marine environment and economy. As mentioned, the two groups, the Diatom Initiative and All Clams on Deck, are the groups that we're focusing on today. And for more information, particularly on those, they have websites and social media that you can connect with. The Gulf Shellfish Institute, as I said before, is the research-based organization. The mission of GSI is to facilitate, support, and encourage increased production of shellfish in Florida and the Gulf region for both economic and environmental benefit through cooperative, industry-driven research and outreach. Now, something that's important to note is the groundswell of organizations, both locally and globally, that are coming to the same conclusion around nearshore marine environments and water quality improvement. While there are different perspectives and approaches, now more than ever, many organizations are focusing on this same goal. Bivalve restoration projects, research on the role they play, and governmental involvement is moving at the fastest pace we've seen yet through coastal communities. These are just a few organizations that have come behind the organization of All Clams on Deck. So All Clams on Deck is a collaboration of so many people who are working tirelessly to help bring your federal tax dollars back to Florida to help with marine water quality. While it has a focus of bivalve and seagrass restoration for improved water quality, All Clams on Deck would like to see that subsequent projects are accountable and designated to include research. The invitation is for all environmental groups in Sarasota, Tampa Bay, and Charlotte Harbor to coalesce around a common theme of biological mitigation strategies for coastal resilience and nutrient mitigation. I love how Ed has said it. He said it's like an invitation to come be part of this science project that's held in one of the most unique laboratories in the country, the only place that has 3 national estuaries on its border. Now, as we know, these estuaries are under more and more pressure each year from poor quality river discharges, climate change, increased coastal development, population growth, and movement to Florida, red tide, and so much more. So this is more than a science project. It's an economic development project, as well as an environmental project. The goal of All Clams on Deck is not only to clean a lot of water, not only to create a lot of jobs, it's not only to increase seagrass growth and fish populations, but it can help save an industry. 80% of clam farmers on the active leases in Charlotte Harbor are no longer working these leases. But if bivalves can be grown for restoration, we're developing a profit-based model that helps the environment and creates good food as well. As I said before, Ed is working to redirect funding. He is looking for an initial $15 million in federal funding to kickstart this project as proof of concept to promote large-scale restoration efforts in our 3 national estuaries. All Clams on Deck is also working to promote the development of mitigation credits, which we're really excited about, for shellfish, as it's already the case with seagrasses. This is being done elsewhere and could be incredibly important to making water quality a greater focal point. So this is where the Diatom Initiative comes in. The Diatom Initiative was designed to almost act like a curious child asking what, why, how. In doing some of these projects, we've been looking at the past, speaking to and collaborating with researchers in the present, and designing methods and projects to ensure that we learn from the future. Bay Shellfish Company was the impetus to the Diatom Initiative. After decades of working with microalgae and bivalves, its team worked with some of the leading minds in both fields in and outside of the US. After all those years of asking questions, looking for answers, and trying to connect dots, I'm here today to relay we still don't have the answers. So I'm sorry if you were expecting something really profound, but we're actually learning, we're still learning. We're learning more and more, and it seems we have a lot more questions. But we do have some thoughts to a new approach to improving water quality based on connecting those dots of research, observations, experimentation, and known relationships between organisms and their environment. So our approach takes a perspective of looking at microalgae first. From there, we consider its role in evolution, and after that, we ask what its role is in our marine environment. So microalgae is a solution that's maybe not easy to see. As we know, excess nutrients in the nearshore marine environment are causing a big issue. It's a crucial problem. And microalgae is a consumer of inorganic nitrogen, removing it from its harmful soluble form and transforming it into product of the air we breathe, food for seagrasses. So this initiative supports the process in which microalgae can bring balance to the system. By looking at the relationship of microalgae with its environment, we then consider what consumes microalgae. In our area, filter feeders certainly play that role. Where is the Diatom Initiative going with this? Well, we have successfully created strategies for increasing bivalves. More importantly, our latest development could do this in an exponential way, we think. The idea has been to create a strategy that is highly cost effective and allows nature to do the majority of the work. To do this, existing accountability and tracing of bivalves and restoration has been insufficient. So we need to and have developed multiple techniques to be able to identify the animals utilized for restoration and then have the ability to look at them from a multi-generational view. So this presentation is not a full explanation of what we're doing, but the concept of what we're doing, we hope to relay in our 10 minutes. Please feel free to contact us with questions that you might have, or if you want to know more about the dots we're connecting or that we're looking at, or into the questions that we're also asking. We believe that by harnessing the basic functions and relationships between microalgae and filter feeders, it's possible to make improvements like reducing harmful algal blooms, like red tide in their size and movement, reducing nutrient pollution in our estuaries, clarifying nearshore marine waters, assisting in the growth, health, and expansion of seagrass beds, creating a more conducive environment for strong and healthy nearshore fish nurseries, and offering marine mammals like manatees a better chance at survival as related to starvation and harmful algal blooms. So I just want to thank you for your time, and thank you, Sarasota Bay Estuary Program, for creating this venue to share ideas and knowledge in a way that considers a multitude of different approaches and perspectives. Thanks so much.
Thank you, Bethany. So now we're moving into the Q&A part of this session before the final summary. And so I'm going to ask all of the speakers again to go ahead and turn their cameras on. And we're sort of compiling some of the questions from the chat and from the Q&A. And there was a lot of really good information in that session. So I'm going to start back with habitat restoration and toss this one to all of you, but kind of singling out Jay and Damon and Randy on some of these restoration projects that you spoke to, both artificial reefs, living seawalls, and oyster reef restoration. What are some of the things that we can do with these projects to have the greatest impact on actually improving water quality?
I'll take a stab at it. There's no question that there are a lot of filter feeders already that exist in our estuaries. There's sponges, there are tunicates or sea squirts. There are a variety of different bivalves that are very effective at filtering the water. So we've established the fact that, we can, in fact, filter particulate matter out of the water column, whether we do it with the Shellfish Initiative, which, I support the Shellfish Initiatives for a variety of different reasons. I support habitat restoration for a variety of different reasons. But in order to use this as a viable strategy for nutrient reduction, I want to see more research. I want to see more examples of these projects actually doing that, rather than all the other benefits that these types of projects can provide in terms of, obviously habitat and other things. I think we're in our very initial stages of determining how effective it is as a water quality reduction strategy or tool. I mean, it could be a tool. I don't know how useful a tool is or how important that tool will be when we are discussing nutrient reductions in the context of wastewater and stormwater and shorelines and everything else. So it is part of the big picture, but I still think it's probably one of those things that's still most in its infancy in determining how effective it is for water quality improvements.
I'd like to add to it if you don't mind, Angela.
Yeah, I was actually going to call on you in a sec, but go for it, David.
I'll go. I'll wait my turn.
No. I was going to ask you about, you go first and then I'll ask you my question.
Okay, so I think Dr. Tomasco brought up a really good point when we first kicked this off, saying that there's no single solution, that all of this is parts of the puzzle. So as Jay was talking about, like these things host millions of other creatures that are also filter feeders. There's biological activity going on underneath these bars that are helping with some of the denitrification. But the other thing I think is really important that people keep in mind is that you don't always have to consider the absolute direct impact that just like the filter feeding aspect has. So like that is going to reduce some nitrogen, but it is going to increase water clarity. With the increase of the water clarity, you're going to increase the amount of seagrasses that are growing. You're going to just create more life in these systems. And that life is what is providing those ecological functions and those services to us that are giving us the kind of the water quality that we want to have. So I think it's really important that like we always kind of keep the ecological aspect of how all these things are related and do everything, do all parts of the puzzle. I like the seagrass part. I like the oyster restoration part. All the habitat parts are really what got me into this. But without doing everything we can do on every aspect of this to have the water quality benefits, we got to do it all. So that was it.
Angela, I would like to make a comment.
Yeah, go for it.
I am afraid to have to be the wet blanket here, but my dissertation research was on estuary nutrient cycles, particularly benthic nutrient regeneration. And there's a lack of understanding of the basic principles about nutrient cycling and eutrophication that would tell us that there is very unlikely to be much significant improvement in water clarity and almost no reduction in nutrient status of a bay or estuary due to filter feeders. We must not allow people to think that they're going to clear up Sarasota Bay or any bay by filter feeding. It's not going to happen. I don't have time to go through the process. Basically, is they're filtering out plankton, which are then has become feces, which are quickly regenerated back to the nitrogen to phytoplankton to have a half-life of 1/2 to 1 day. All they need is the nutrients, and the nutrients are coming back to them. So these are all good for their various purposes. Yes, I like the habitat values of them, but we should not let those kinds of efforts take our eye off of the ball which is that of reduction of nutrient inputs into these systems. That's my comment.
Thanks, Randy. I'll go ahead and I bet Kurt would like to respond to that. Or Bethany.
Sure. Yeah, I'll gladly and wholeheartedly respond by saying that, you know, research in the past is exactly that. We can learn from the past. We can look at the past, and we always should. I think that new things are being learned every day, and I think that the second we close our minds to what we think is happening, I think the first thing that was just said by the last commenter was that we didn't know the processes that were occurring. But to rule out filter feeders and their full integration and how they interact in the environment, I think is incorrect. I have stronger words that I could use, but and I'm not coming from a bias. I literally am taking the the viewpoint that there is a lot for us to learn. There's a lot that we should be doing. We're learning every time we do a project, whether successful or not. And I'm talking about the projects of presenters that have spoken today. I certainly appreciate everything that Damon Moore said, because I think that the second we don't think we are actually the children in this scenario of the environment, we really know so little. I think we're doomed to fail when we don't keep that open mind. And if for any reason we think that from an evolutionary standpoint, microalgae, we trace back to 1 billion years ago, 600,000 years after, or 600 million years after that, became certain types of filter feeders. If we think that Mother Nature and evolution hasn't already, that's what created these cycles. That's what created the movement of nitrogen and many of the other cycles. I think that we need to look, if we're going to look to the past, at some past research, let's look back 1 billion years. Let's look back 500 million years. Let's look at why these things occurred, why they are occurring. What's the likelihood that they occurred for these reasons? I mean, there's so many questions to ask. And I think that when you say you have a species from an evolutionary standpoint that was around before, 99% of all the other species that we see on our planet now, and we don't think that when they're missing, there's a problem, I think that's fairly ignorant. And to say that we have bivalves in our environment, yeah, where are the bay scallops? There's all kinds of, if I go to Dr. Bill Arnold, who headed up the Mussel and Fisheries division at FWRI for years, and I ask him the simple question that we should be asking. What were the historical numbers of, I don't know, a scallop, an oyster bed? What were they before we took pictures? What were they before we recorded things? What were they before mankind's intervention? The answer is he doesn't know. We wish he did. We wish we had those answers.
Well, yeah, and I think that was a really informative part of Damon's talk with the historical perspective in the shifting baselines, in the Manatee River, and how much oyster habitat used to be in the river.
However, I must respond. There is plenty of basic science that we don't need to look at squishy evolutionary past and so there's basic science that tells us what will go on, what does go on, and those kinds of things. I don't care what anybody's own opinion is, but if we start giving people that false impression that things are going to do what they're not going to do, we will hurt our bays and estuaries by taking the eye off of the real problem. That's it. Okay.
A lot to think about. I've got another one for you guys that's coming in here. So one of the questions we had was how temperature and salinity impact oysters and clams for that matter, actually. But Damon, you mentioned the difficulty in getting permits for some of the oyster reef restoration efforts that have been going on already inside of our estuaries. So how do you figure out where the best places are to put these habitat restoration efforts, get the most bang for your buck?
So I mentioned at the beginning of my presentation that I come at this from a practitioner standpoint. I always work very hard to close any gap between practitioners and the scientists who've dedicated their life to the study of it. So I kind of dive into the research as far as basically learn enough to make myself dangerous. And then what I really prefer to rely on is prototyping. So if we're going to make large investments of taxpayer money in this scenario in restoring, oyster habitat, I want to know if it's going to work. So for that, in the Manatee River case, Jay and I went out with dish racks full of oyster shell 2 years ago and laid them down on the bottom of the river every 2 miles to say, where do these oysters grow? We found out where they grow real well and where they're a little bit slower so that we can use that information to inform those projects. But Jay and the other people with more letters behind their name can probably speak a lot better on the specifics of exactly what the water chemistry aspects and all that are. But I like that. And one of the things I really love about our restoration community in this area is that we all keep an open mind to that so that we don't get analysis paralysis. We can move through with these big projects, but that, us restoration practitioners also aren't just going out and tossing stuff in the water to see what happens. So it's a great team effort. I personally, my fallback is to prototype it and see how it goes, and then make informed decisions off of that. But that's before that, it's literature searching and talking to people who know more about it than I do.
I'll follow up real quickly to say this really worked well for oysters because there's been more research, more practice, more experience regionally, globally, locally with oysters. And so it's not really, it's science, but it's not rocket science. And, I think that the determining factor is more the salinity than the temperature because of their, there's a sweet spot for oysters. And so it's really finding the sweet spot where they are. And we've shown that we've been pretty successful with oysters. And I'll let the others, talk about, we've worked with scallops. Scallops are a little trickier. Certainly, Kurt's group, knows more about clam growth, restoration, the industry. So in terms of oysters, I think Damon and I have a pretty good handle on that.
Okay, let's get back to living shorelines. We have about 2 minutes. And so a question about living shorelines that has come in. Okay, so we know that the structural complexity is important for fisheries habitat, but we also know that there are some serious water quality implications for not having living shorelines or these complex shorelines and just replacing them with hardened seawalls. So what are the best ways to get some of these efforts to have more living shoreline type areas in the hands of the developers, and making sure that people that are doing coastal development follow, change the old way of doing things? I hope I phrased that correctly. Paraphrase.
If I can just be brief about it, I think that it is a challenge because to date, most of the projects have occurred on public lands, and it's the responsibility of those of us who have been successful at doing it on public lands to showcase those projects to the private sector, particularly waterfront, whether it's waterfront residences. And so I think, in my opinion, it's got, number one, it better look attractive and pretty, or else nobody's going to want to do it. I don't care how effective it is. If you really want to get the private sector in there, it has to be an amenity. It has to have an aesthetic to it. So I think it is still a challenge. I think there have been very few that have been done on private lands, but we have shown benefits to them. We can make them attractive. We can make them effective. We can show the benefits of them. So I think it's mostly continued education and outreach and getting people to know more about them and get them excited about them, get them to want to do it, and rather than just saying, oh, okay, tell me why I should do it.
Can I make a comment?
Yep. And then we actually, Randy, I'll let you make a quick comment, but I got to cut it off here at 3:20. So go for it.
I don't want people, again, to get off on things that are not realistic. Living shorelines is a big topic with NOAA, and I think it has great promise, particularly in the mid-Atlantic states, where there's still large areas of natural shorelines or only slightly modified shorelines, not big residential seawalled canal developments. And we in Florida, we just don't have that much area. So we have to work with living shoreline. But I have also thought in terms of artificial habitats along seawalls, there are opportunities. I have considered, for example, well-designed planters where you could install a planter along a seawall and grow a few mangroves, allow the homeowners to have the option of trimming those so they don't obstruct their view, things like that. Realistically, people are not going to tear down their seawall and turn it into a living shoreline in very many cases. So we have to work with what we have and deal with what we have.
Right. Yeah. Agreed. There are a lot of don't let perfect get in the way of good, to steal what Dave said earlier this morning. So on that note, I've got to cut this off here and turn the microphone back over to the Sarasota Bay Estuary Program. I'd like to give another virtual round of applause to the afternoon session speakers. That was a lot of information and really, really informative. Thank you guys so much. I apologize if we didn't get to your question in the chat, but I know that Darcy will be amazing in making sure that everyone's questions are answered here at the end. And so with that, I'm going to hand it back over to Dr. Tomasco for concluding remarks and wrap up.
Thanks, Angela. Give me a thumbs up if this looks good. You can see my screen.
Looks good. All
right. So first off, I wanted to thank everyone here, the audience, for hanging in here. We've got, what do we have? We have 140 people roughly who are still attending after like several hours. I wanted to thank all the presenters. I'd like to ask if the presenters could mute themselves. I wanted to thank, in particular, the people who moderated this. John in the morning did a fantastic job. Angela did a fantastic job. And I wanted to thank, our staff here at the Estuary Program. If we're successful, it's because the quality of the staff we have here. We have Cheryl Dexter, we have Jay Leveroni, we have Heather Moody, we have Christine Quigley, we have Darcy Young. This thing would have been a train wreck without Darcy in particular here. So just want to give you a heads up that if you want to know if this went well, it's not because of me. It's because of Darcy and the others here. But so what did we cover today? Okay, so the things that we covered today are that we're farther along than some might have thought. And we really are. We were actually pretty far along the pathway of figuring out what we need to do. So let me go through a couple of steps of what we went over. We have a peer-reviewed report card. When we talk about things here during this workshop or our meetings, it's not Dave's opinion, it's not the Estuary Program's opinion. When we talk about specific goals and that sort of stuff, it's a peer review process we go through. Our technical advisory committee has got dozens of people with literally centuries of experience in Sarasota Bay. So we've got a report card on Bay Health. It's more important than people might think it is, because within that report card is a reference period. And that's a really important thing for us to look at. It's also really important that it not only passed our technical advisory committee, it passed our citizens advisory committee. These are the folks that are out on the bay a lot more often than someone who might be a great statistician, a great modeler, a super engineer, but who's only been out on the water maybe twice in the last couple of years. These folks are out on the water all the time. They know it, they're smart people. But also our management and policy committees. So our management committee is basically resource managers at the executive level, the folks that could say, yes, we're behind this as an agency. Our policy committee is elected officials and appointed officials. So we have policymakers, resource managers, the citizens, and the technical advisory committee all behind how we represent the Bay's health. And that's a really important step. But we couple that with a peer-reviewed pollutant loading model, all right? The pollutant loading model, as we've been saying over and over again, don't let perfect be the enemy of good. Don't get into paralysis by analysis. There's always going to be questions about what we have in terms of data gaps for pollutant loading models, but we have to move forward anyway. Remember that deterioration in the Indian River Lagoon happened in about 10 years. We don't have 10 years to refine our knowledge to be perfect about what we need to do. But it does look like if we compare those two time periods, when the Bay had multiple indicators of being healthy versus where we are right now, that the difference is perhaps something we can get to, that the nutrient increase during that time period is smaller than the controllable loading sources. And that's a really good thing, because nutrient loads are not the only thing we need to pay attention to. As in the last session, we don't want to ignore what more filter feeders can do, But if you look at large-scale ecosystem restoration projects that have the track record of success, they didn't expect filter feeders to get them the water quality improvements. They expected load reductions to do that. And filter feeders were something on top of that. So we have lots of strategies that can be implemented in addition to all the work that you saw from those local governments. We have the groundwater denitrification projects that Steve Swall talked about, the stream restoration benefits to water quality that Mary talked about, enhanced stormwater pond design and maintenance that Sandy spoke about, and smarter use of nutrient-rich reclaimed water that was talked about by Abby. So again, there's nothing wrong with reclaimed water if it's appropriately used, but if people are using 80 inches with 18 milligrams per liter and fertilizing on top of it, that's a problem. And that's a problem that's not going to cost any money to fix. It's going to cost education, but not a huge government-run program to fix that. Plus, as we went over in the last session, there's the expectation of water quality benefits of habitat restoration. Oyster reefs. Damon's really cool work that he talked about is in Manatee River. That's not actually in our watershed, but it doesn't matter. We're a big fan of it anyway, because it actually is in our watershed, because it affects us when the Manatee River discharges come around the corner. One of the things that we've actually found is that sometimes oyster reefs are found in places where you don't expect them to be. So the idea that like Damon and Jay were talking about, which is like going out there and seeing whether or not you actually can use their existing depleted occurrence as a kind of an indicator of where to grow, that's a great idea. Artificial reefs along hardened shorelines, like Randy talked about. Why would you ignore these finger-filled canal communities? You've got 100 miles, I think in Longboat Key alone. We have to do something with them, or are we just going to let them be just clear walls with very little habitat value? Why would we do that? So there might be permitting hurdles we have to go through to figure out, maybe there's a material switch. Maybe we don't do PVC, maybe we do something else, you know, but it doesn't make sense for us to just give up and do nothing in all those miles of hardened canals. And the open waters of the bay, clam deployments, all these sort of things. There's nothing wrong with using biological materials in the bay, but don't expect them to fix the bay by themselves. Expect them to be something that you do in addition. They're going to have ancillary benefits in addition to the habitat. The habitat value uplift by itself is enough. So this table is a summary of what we got from the morning session. This is local government completed or future capital improvement plans for stormwater and wastewater. And just wanted to give you a moment to look at that. So if we look at the past projects that we got, the amount of money, this is in millions of dollars, it's $400 million. That does not include the cost of upgrading City of Bradenton to AWT, City of Sarasota to AWT. If you include both of those, it's well north of $500 million. We didn't include that because we asked them to do the last 10, 20 years, and those two plants were upgraded 30 years ago. The future projects, those future projects are nearly $1 billion. And this is one of the important things. You know, we're basically far along this pathway because we already have local governments willing to spend the amount of money that's going to be necessary to get us the nutrient reductions we think that are going to be necessary. So the past and future project cost estimates don't include the cost of the water quality and natural resources monitoring efforts, the seagrass mapping efforts that the Water Management District does, the habitat restoration projects that Jay talked about, that the Water Management District splits on habitat restoration. Those aren't even included. That would increase it even more. So literally, we're talking about past and future $1.5 billion that has been spent or will be spent on managing the bay. And the reality is that's what it takes. If you want to play in ecosystem restoration on a large scale, you have to be willing to understand how much money is involved. We can't get excited about $40,000, $1 million. It's not enough. It's enough to keep people busy. But if you really want to do habitat restoration on the scale of an estuary, this is what it takes. This is what it took in Tampa Bay. This is what it's going to take for us. Tampa Bay's estimate is $2.5 billion already spent to restore the Tampa Bay water quality that we have right now. And that's not including what has to be done in the future. That's how much it costs. This is why we want people to realize our estuary program is kind of set up this way. We want to be like your car mechanic. If your car is making noise, if it's shimmying, if it's just not running right, you go in there and you want to have 3 questions answered. What's wrong with it? What are you going to do to fix it? How much is it going to cost? Well, guess what? We know what's wrong with Sarasota Bay. We kind of know what we need to do. And this is kind of an idea of what it's going to cost. So what are our future actions for water quality specifically? One of the first things is a more formal summary of what we went over today. This area right now has a number of water quality impairments. And if we sit back and do nothing, we're going to have modelers in Tallahassee or Washington, D.C. or private consultant tell us what we need to do. Our technical advisory committee, our policy boards, they don't want to do that. They want to go through what we call reasonable assurance plan, which is sort of like a locally led TMDL. We would determine what is the appropriate target for bay resources. We've given you an idea, a starting point, but that doesn't mean that's what the final number would be. We would review the proposed projects. Earlier questions were, hey, Mike Milet, how much of a nutrient load reduction is that going to bring about? We don't know yet, but we're going to get that answer. That's going to be part of the process. That will help us develop a pollutant load reduction goal, TMDL allocation. That'll help us figure out exactly what the load reductions will be for the anticipated projects. If we meet that, let's say we find the load reduction, we do it. Is it time to relax? And I think the answer is no, clearly no. And I think that we got too confident in what we were expecting to happen. Those huge load reductions in Tampa Bay and Sarasota Bay, they took place decades ago. The big reductions that got us the improvement in water quality, the 40 square miles of new seagrass, we didn't plant it, it came back. That's based on the biggest load reductions took place 30 years ago, but then we kind of didn't do enough. We had 30 years of population growth and we didn't offset it. And we're not going to do that again. So once we get to the target loads to get us the condition that we agree is a helpful indicator of the healthy bay, then we need a hold the line strategy. We have to offset population growth. Some people think you can't do that. You can do that. It's been done. Sarasota Bay and Tampa Bay are not as healthy as they were a couple of years ago, but they're both healthier than they were a couple of decades ago when we had fewer people. You don't have to have degradation of the water quality because you have more people. It depends on what you do with that stormwater, with that wastewater, with their reclaimed water, with public education. But what we also want to do is we want to basically take into account the potential implications of 30 years of sea level rise. What is that going to do to our bay? And it's not going to be necessarily scary, but it's something we need to take into account. And what we'll also do is we'll set up a program and a reasonable assurance plan to monitor our progress on both the actions and the responses. If we put a lot of effort into doing wastewater and stormwater and we see no system response, then we're going to have to figure out what the heck is going on. That's never been the case before. It doesn't matter if it's Sarasota Bay, Tampa Bay, Chesapeake Bay, Denmark, or Australia. We've always shown improved water qualities going after pollutant loads, particularly from wastewater, but also from stormwater. But we're going to report on it. And we're going to report back to stakeholders to make sure that we actually don't just speak amongst ourselves. We let the public know what we're doing. So is there enough political will to get the job done? I think the answer is pretty straightforward. Yeah, we have two possible futures. We could be like the left. This is an actual photo of Indian River Lagoon. On the right is Sarasota Bay. Which future do you want? Because the reality is in Indian River Lagoon, they don't want to be where they are, and they didn't think they're going to be where they are, but they're there. We don't want that, and we better start doing a better job than we have the last couple of years. And because it's not only quality of life, it's what our Florida wildlife heritage is like. Do we want to have our wildlife look like it is on the left-hand side, or do we want to have the impacts to our wildlife like we're seeing on the right-hand side? And I have no desire, and neither does my staff, to see what we're seeing on the right-hand side pop up in Sarasota Bay. So with that said, we don't expect to have everyone feel comfortable with comments and questions. So please reach out to us, www.sarasotabay.org. Email us. My email is dave@sarasotabay.org.